Right. Let me mute the stream first. So the Buildspace Nights and Weekends project started yesterday officially. They had a Zoom call going on, and Farza explained how it's gonna be and what they are expecting. And I thought a lot about what I'm gonna do. And the thing is, the most challenging thing for me is I don't want to pick something that is too hard that I won't be able to finish in 6 weeks. And I have no idea what I'm capable of building in 6 weeks. But at the same time, I don't want to pick something that is too easy and then it's just gonna be trash. So that's the biggest debate that I'm having. I'm still having right now, but from what I understood about the things that he said, it's pretty much the main priority that you're able to ship something and you have a link, and every week you make some kind of progress on that. I think that's the main goal of the project, and that's the point of the project itself, is to get you off localhost. So yeah, so I think what I'm gonna do, at least that's the idea I have right now, is I'm gonna improve the project that I already did for the Silo network, which is the NFT marketplace, which is kind of the bad thing about that is that I don't really want to do NFTs for JPEG stuff. If I'm gonna do something with NFTs, I wanna do it in a way that brings real utility instead of just allowing people to trade JPEGs. But the problem is all the other ideas that I have, I think is gonna be far too complicated to make in under 6 weeks. So I think that the best approach is probably to work on this, on improving this as much as I can, on the shortest amount of time that I can, and then once I have something that is decent enough, I think I'm gonna try to either create extensions to improve this, or try to make other projects and ship those other projects before the 6 weeks mark. Then the worst case scenario is I have the NFT marketplace to show. That's something that I shipped, and I was gonna say something else as well that I forgot. Now this is the one that I did for the Silo network. I redeployed the contract, so there's no NFTs here, but there were some NFTs before. And it's because someone left comments. I think was this guy here, Rafael and Donga, and he saw some problems with the contract, so he made a pull request, and I decided to merge. And like I said before, even before nights and weekends, I was planning to improving this after I got done with the timeline for the decade stuff. And I guess it's gonna be a good idea to improve on this. And then maybe try to create Chrome extensions for this. And then maybe try to work on the other projects, getting the data from the blockchain, which I'm getting here. I'm still getting the blocks. I'm at 7 million, roughly. Oh yeah, the other thing I was gonna say is that I will see if the idea that I have right now is over the next week, work on improving this project, and depending on how far I go for the other week, I think I might try to do all the Buildspace projects and get all the NFTs, because the previous times that I did the projects, I wasn't doing with the intention of finishing. I was just doing it to get myself familiar with the blockchain and Solidity and NFTs in general. And I wasn't really planning on, I didn't really care if I finished or not, or if I completed the steps correctly. So I think one idea is also to see if it's possible to submit that as a how can I say, as a ship project. So I'm thinking about doing all of them. So I get all the NFTs on my profile, and after I do that, then going back and seeing if I can continue. Because the project that excites me the most is this one, which is getting data from the blockchain and getting these addresses and seeing what kinds of connections I can make. And I want to explore the decentralized exchanges and other companies and the entire ecosystem in general to be able to capture what are the relationships between transactions that people are making into this chains, to analyze the flow of money and try to extract something more fundamental about that, about social structures and market economy. But it's still the problem with this project is that I'm still not sure what the end goal would look like and how hard would be to finish this. And that's why I think I can't really choose this one as my main project, at least in the beginning. So yeah, I'm not really excited to. That's the issue. I'm not really excited to improve on this one because it's not really something that I see a lot of things that I can do with. At least for now, I couldn't think about good ways that are gonna be relatively easy that I can do in 6 weeks to implement NFTs and real utility. All the ideas I can think of are a lot harder to implement, and they will probably require money and several other different things going correct, or talking to people in real life and doing all sorts of things. So because in order to make NFTs work, you have to work with politics, and you have to change the systems in place. And that's a lot harder to do than just to create the technology. You have to change people's mind and educate and change the rules, and that's very complicated. And right now, I really don't feel like doing anything, but I have to. So yeah, that's what discipline is all about, right? So you gotta do. Sometimes you gotta show up when you don't feel like it. So I think what I'm gonna do today is just study. I was looking at this stuff here. Off stream, I also spent a bunch of time studying a bunch of different things and reading books. I also got a new book, actually 2 new books about network connections as well that I will be reading throughout this thing. And what I was doing off stream, was looking at how to connect, because the first step that I want to do here is change because previously the way that I was connecting here was using the use contract kit from Silo Network, which is a React component built in for the Silo Network that allows you to get the wallets and to get the address and connect the user to the wallet, connect the wallet with the front end. But because I want to do on Polygon instead of the Silo, then I have to remove all these connections from the Silo network using the use contract kit, and I have to figure out a different way to connect the MetaMask or any other wallet with the front end. And it's actually a lot harder than I thought it would be. Actually, it's not that hard from what I've seen. But the problem is that there are multiple different ways of doing it, and I'm not sure about the design, which one is going to be best for this project. That's the most difficult part, I think. And it's kind of what I'm stuck on right now, is that it's not that I don't know what to do or how to do it. It's just that I can't figure out, I can't decide which design is going to be best. So the last thing I've done, which I think it might be the best, but I'm not really sure, was create this file here, use wallet connection. This one is the file that these 2 files use. And these 2 files allow for me to get the contract abstraction in the front end. So this is the NFT contract, and the other is the marketplace contract. Oh, that's another thing that I'm going to do, which is change this smart contract from the way that it was before, and maybe add a bunch of other smart contracts. And I think I'm also gonna study the C apart contracts, which I already downloaded. I cloned the repo some time ago, which seems to be the most advanced one so far. And it is from OpenSea. There's also a bug bounty, I think, of $1 million for finding a mistake on this one. But yeah, I won't be focusing on that, obviously, because it's probably really hard to find it. And my main goal is going to be more to understand what this looks like and the design of the thing. So pretty much these ones use this use contract, which is this other hook here that exists on this folder. And I changed some stuff here, which was using the use contract kit as well. So I changed to getting the provider using Web3 provider and window.ethereum. So as far as I know right now, the window object is going to contain the wallets if you have the wallet. And if you don't have the wallets, then it's going to return undefined. But when you have wallets installed, you can access those wallets through the window object. And that's what I'm doing here. And if you have Solana, for example, if you want to get access to Phantom, which is a Solana wallet, you would put Solana here instead of Ethereum. But since I'm going to be doing on Polygon, it's fine to do like this, I think. And then this is the same thing I was doing before with the contract kit, which is to get the address of the user that's going to be signed in. So I haven't tested this one so far, so hopefully it works. But the idea is you get the provider and then you get the signer, and then you create the contract abstraction using the ethers library and contract here with the ABI and contract address. And these files with the ABI and contract address are created when you deploy the contract through this script here, which has this write file sync. And the deployment happens here. So I'm probably gonna have to modify this file as well. Maybe create other deployment scripts, because I suspect I might need more than 2 contracts. I already replaced the contract here. I also went through the tutorial of Free Code Camp from this guy named Patrick, I think, which is really good. I love his videos. He's awesome. So far, I watched a bunch of his videos and all of them were really helpful. So I was setting up everything with Morales and then graph. The graph, which is similar to Morales, which is pretty much a way for you to get information from the blockchain based on events in a decentralized way. Morales is centralized and the graph is decentralized. Oh yeah, and I think now I'm also going to study the scaffold if and the Ethereum speedrun, because the way that he does things is probably the best way. I was looking into this as well. The way that he connects things. I was studying his contract, not his contract, his project, but it seemed very complicated, so I decided not to do it. But then now I think I'm going back to it because I think it's probably the best way, even though it's the most complex way to do it, to connect users with the front end. So yeah, then I changed this thing here. And then these ones, I just deleted the contract kit from here, the import statement, because I want to remove everything. Another thing that I realized as well, and maybe if you're someone watching this and you're gonna develop something and you're not very experienced, you're probably gonna run into the same problem, which is I feel like I don't want to mess anything up. So that's kind of something that is holding me back from modifying any of this, because then you don't want to modify and then screw things up and then ruin the code that you already have. But yeah, the way that you deal with that is just creating a different branch, and that's what I did. And that's why having version control is useful. So I just created a different branch, and now I can mess everything up. And then worst case scenario, we still have the main one with the code from the beginning. And obviously I also have the other project as well in other folders. So, but it's definitely kind of scary to delete things, and because then you might spend a bunch of time trying to figure everything out again. You're pretty much starting from scratch again. So both in the profile page, the explore page, I have to find a way to get the address of the user, because I was using the address to compare here to filter the NFTs. I'm probably gonna change the whole UI as well. So I'm probably gonna have to change everything slowly. But I think it's better to start with this code here, because there's already a bunch of stuff that I have. But I suspect that in the end, it's gonna be everything different, because I'm gonna change the smart contracts as well. So one of the ways also that I was seeing is using this use Web3 React to connect the user. So there's this way. There's a way where you just check for the window object, and then you put the Ethereum, and then you make checks based on that, which I believe some of the Buildspace projects use this way. And then the other way is using something called Web3 model, which is the one that I think I'm gonna use. And the way that I think I'm gonna do this, the last time that I stopped seeing this, is creating this file here, and then putting all the logic for connecting the user on this separate file, and then using this as a hook on the other pages, because I don't want to repeat myself every time I want to connect the user to write the whole code again. And another thing that is not really clear to me is that I didn't realize when I was working before, because I had the kit, is that you need to find a way to maintain the state of because obviously if the user signs in one page, you don't want to have them signing every time they move throughout the site. So you need to figure out a way to capture that state and not lose it, if that makes sense, whenever the user navigates through the page. And I'm not really sure exactly how is the best way to approach that, because the way that I was doing before, I had the connection on every single page. I was using the address, but if I change things up here, I might have to change everything, because the navigation, the way that I did the navigation is in all pages, so it's outside the routes here. And yeah. And the navigation contains the connection, the buttons to connect here, which are, let me see if I have here, which is this button here. And this shows up in all the pages because it's outside of the routes. But the others also were using the use contract kits as well. So now I'm not really sure if I should replace the use contract kit on this page and remove from all the other pages completely, because this is going to be the only point of connection to the wallet, or if I should change these pages as well. But I think I'm going to have to find a way to get the address as well on this one and this one, because I have to use the address of the user wallet to filter the NFTs. I think that's the main thing I'm going to do, is figure out how to connect. And I think that's what I'm going to do. So from using use Web3 model, you get the provider, and then you create an object with the options. What is the const? I have not seen it used before. Which page do you mean? app.js. So this here is another thing that I saw from a tutorial, which is when you're going to use Web3 to help you connect users. The stuff that I was talking about with the context is, if you put this wrapper here, is going to allow you to retain the context in their entire application, so that the user doesn't have to reconnect every time when they're navigating the website. And apparently this is what you use, but I'm not really sure if this if this goes along with the Web3 model stuff. I'm still not clear on that. And I was watching a video of a guy explaining the source code behind these things, which I think I'm gonna do as well. And I don't think I installed this thing yet. I just put it there because I saw in the tutorial. But I'm gonna check this out now, I think. Oh, let me know here. I can go page by page and then let me know if you see it. You're talking about this thing here. But whenever you put const, and I'm gonna write it down. Whenever you do const like this and you make it equal to something, that's called destructuring. So what's gonna do is take the value out of the object. So usually what you're gonna have is an object which is like this. Oh, just the syntax? Okay. So let's say you have an object like this, where you have a key which is high and the value which is hello. If you don't do like this, if you just do like this, let's say this is the object, right? Then whatever value is gonna be here is gonna be equal to the key. But when you do it like this, you are actually capturing the value because you're destructuring the object. So this is useful if you don't wanna. So essentially, let's see. Let me put hello here. So if you do it like this, you can call this with hi. But if you don't put it like this, you would have to call it like this, hi.hello. So it's essentially almost the same thing, but it's just easier when you destructure because you don't have to type the previous word first every time. You can just type the word and that word is going to be equal to the value, not the object. That makes sense. So when you have the curly braces, instead of getting the key for activate, you're getting the value which activate points to. So activate equals to some value. When you put this, then whenever you say activate, you're actually getting the value here. And when you don't have the parentheses, you're getting the key. So in order to access the value, you would have to type it like this on everywhere that you use activate. So it's just an easier way to, but it can be very confusing. And in some instances, it is still hard for me to understand completely. Yeah, syntax sugar. We from Java don't have any of this. We have to read some more. Oh, Java is probably a lot harder actually to know, so I'm sure you won't have any problem. The hardest part about React that I found so far is understanding props, which is the value that is passed here inside the functions, and understanding state. Because in order to understand these things, you have to think about the whole application and the flow of data in the application when you're building, and that's really hard to do. So in React, it always goes top down. So the higher level component, there are some tools that allow you to jump from one side to the other, but usually you're gonna have a component at the top, and then that component is gonna pass data to the components at the bottom. But if you wanna pass data from one component at the bottom into the other one, it's a lot harder because you have to find a common tree that links them and pass the data from there. Or you have to use something that is called useRef, I think, or useContext. And that is gonna allow you for you to pass data from this point into this point. And that's very complicated. And it's essentially the thing that I'm talking about here with the wallet state that is really confusing, because how do you decide what's the best point to get the user connected to the application? And how do you maintain the connection over all the pages? It's really tricky to know, to think about what's the best way to do that. Yeah, that's React. Yeah. And I think Next.js is very similar to React, is the same thing, but has some additional tools as well. But it's pretty much the same thing. And React gets a lot more complicated as well when you put TypeScript and you use Redux to manage the state. And I don't have a lot of practice with that as well. So it's kind of hard to decide when you're gonna incorporate some of this stuff and when you're not. Yeah, so this right here I got from the scaffold Ethereum, from that guy that's really awesome as well. I really love his videos and his tutorials. He really knows what he's doing. This, I think, is pretty much the same. Yeah, I just copied this one from his project, and this is scaffold if, which is pretty much a built-in project with everything that you need pretty much in order to teach you how to do it. And he has a Ethereum speedrun stuff that is kind of like a series of tutorials that help you understand what's going on. So I want to use this, I think. I'm going to use this and try to modify for my case and try to understand what's going on here and how can I do it in my way, so that I remove all this stuff and do it with this way instead. I've got a web dev bootcamp coming up and includes React, so I'll probably wait until then to prevent bad habits for me. Bad habits? What do you mean by that? Bad habits? I think that's just, yeah. Interesting. Yeah, but I don't know. I'm not sure you can really prevent bad habits. I guess, yeah, I suppose so. If you learn and then you implement. It's still something that I'm struggling with because it's not. It's very unclear, you know. Because usually there's multiple ways of doing things, and it's very hard to decide which one is the best. And I think this only comes with experience because it's more about the design of the whole thing, and the design changes for every project. That's the problem. So there isn't really a way for someone to tell you this is the best way to do things, because it's gonna be very specific to any project that you try to do. And I guess that's something you just get from experience. But it's hard. It's very hard when you're beginning and you're trying to decide which way to do things. So far, that's the part I found the hardest of building these things. It's not necessarily that you don't know how to do it. It's just that it's very difficult to commit to one way of doing things. And I guess that's what's holding me back here in this case as well. Because I've looked at a bunch of different tutorials, and I also know a bunch of different ways now of doing things, and I've seen multiple different projects as well, and I just don't know which one to pick or what to do. No problem, man. This also I got from the scaffold if, but this is just a standard way that you always do to connect people. You have this object, which is this module that you create and you export in the hard hat config file, which comes from the hard hat configuration. The initial commands you built the hard hat with npx, I think, if I remember correctly, or npm. And then you put the version of Solidity, and then you put the networks on this object here. Then you put the name, the URL, which is the RPC. And the RPC is pretty much the bridge between the blockchain. It's the way that you communicate from the JavaScript with the blockchain. I still don't know really well how it works under the hood, but yeah. And that's the stuff that you have on your MetaMask as well. Every time you're gonna connect a new thing, you have to put the RPC there, which is pretty much the connection. Yeah, so it puts chain, RPC, symbol, in the explorer. And then whenever you're going to deploy, you specify which network you're going to deploy to. So there's also faucets that you can get. Usually that's how it's done. You have a faucet, which is pretty much a way for you to get fake whatever coin you're going to use on the same. So let me show you here. So this is the Mumbai testnet. So this is fake money. And this is the same as the Polygon mainnet. So usually what you do is you get money from a faucet for the testnet of whatever blockchain you're going to test. And then you use this money to deploy the contracts and test them. And then once you see that the whole application is ready and everything is working, then you deploy to the main one and spend real money. But the biggest issue that I still don't know as well is that how people update the contracts, because the problem is after you deploy the contract, you can't really change it. You can just redeploy again. And I have no idea how people do to maintain the state from one version of the contracts into other ones once they want to update something. So that's something I have to look into as well. Because obviously you don't want to lose all the information you have from other contracts, but at the same time, it's inevitable to have to update things. So I'm not really sure how people do that in practice. Being able to question, get confirmation, etc. really helps with learning. Started JS on Monday and was able to pass all tests in the bootcamp interview. The goal was half of the questions, and I got the highest score they've had. I believe the others are absolute beginnings. I'm at a spot to be able to efficiently teach myself, but I don't have a degree or work experience, so it's additional info I can put into my resume. Interesting. How did you start it? And why did you select Java to start? A lot of people select Java, and there's this guy on YouTube as well. He said he read the book Head First Java, and I think, and he learned everything, and he said it was really good. And I also saw Java or similar languages to Java on chess websites. So I guess Java is a really good language for gaming and applications that require more dynamic or WebSocket connections and things like that, or more dynamic. But I don't know anything about Java at all so far. And I think I'm not gonna learn it because probably it's too hard. It's gonna deviate from what I already know. So it's probably better to learn the stuff, but at the same time, I'm not sure. I think I'm gonna delete this Morales idea. I think I'm gonna go with the graph instead of Morales to connect to get the event information from events on the blockchain, because I want to find a way to. So the graph is supposed to be less efficient, but is decentralized. But not is. I don't believe there is anything that is fully decentralized, but it's more decentralized than a normal application. And Morales is more centralized. So I'm thinking about going with the graph because of that. And I also have to replace this. So these are all from Infura, which is an RPC, which is an API provider that allows you or helps you to connect with the blockchain. And that's why you use this URLs here. So whenever you're gonna deploy, you're actually accessing the API from Infura or Alchemy. In this case, it's Infura because that's the one that he decided to go. I have accounts on both of them, so usually I prefer Alchemy because Alchemy you can use more, and Infura has a limit, I think. But just for deploying, I think it's fine because you're not gonna make too many calls. So I have to replace these IDs here with my own ID, which I have on the environment variables, which obviously I'm not gonna show. So I think I'm gonna put this copy here. And the annoying part is that I have to change this as well. On all of them. I think what I'm gonna do is try to... So first I'm gonna change this stuff, so I have all the IDs correctly. Then I'm gonna try to understand this connection here from the scaffold if. And then I'm gonna try to see if I can incorporate this file into the other ones to hold the connection. And yeah, that's the part that I'm most concerned with, to be honest, because I know there are gonna be a lot of problems, and I'm not sure how long it's gonna take me to solve all of them, but I have to start, so. And then after I have changed all the connections, what I'm gonna do is, I think the first thing I'm gonna do is look into the OpenSea and see what kind of features they have there. And obviously, not obviously, but I think the main one and the first one that I'm gonna try to implement is the profile, because the profile is gonna be on Web 2.0. So I'm gonna have to connect the front end with back end. And I'm not sure which backend I'm gonna use, but I'm thinking either Flask or Django. And I think I'm gonna select Django because even though it's harder, it's probably gonna be better to learn and is more scalable, I think, for bigger applications. Then once I have the full stack thing and I can deploy to a site, then I'll think about the structure of the contracts, because I think that's gonna take more time, and I need to have the link as fast as possible so I don't get so I'm able to ship it before the date for the next date for the nights and weekend stuff. I've been coding a while as a hobby. I began when I was playing Minecraft, as it was used to create plugins for the server. So I was quite fortunate to not learn it. Just did things until I got what I remembered. Okay, to actually learn Java, it was super easy. I know C, Python, and C# too. Damn, C is very, very difficult. Do you actually know C, or you just know the syntax? Because I think I know C++ as well, but I just know the syntax. I don't know how to code in it. And it didn't seem that hard for me to learn the syntax, but people say, yeah, it seems like it's very, very hard to actually code in it, because you have to handle memory, and people always complain that this is really hard to do. Which is another thing that I'm not sure if I should put or not, because I learned, I've done courses on TypeScript, Rust, C++, C, all these different languages, and I think I know roughly the syntax, but I never coded in them, so I'm not sure if I can be comfortable enough putting them on my resume or something like that. So probably not, right? It all becomes easy once you know the fundamentals, just syntax and features you need to learn mostly. Got what I wanted at the beginning, HTML, CSS, and JavaScript. Now I think they're just overall good skills to have. Yeah, no worries, man. Thank you for the convo. Yeah, see you. Rust is another language that I kind of want to learn, but it's gonna take a while until I learn it, because it's very hard and probably not practical with the stuff that I'm doing right now. So I think I'm gonna focus only on Solidity, to be honest. C-lang, not C++. Yeah. But C is just C++ without objects, as far as I know. And C++ seems easy just based on the syntax, but I know it's very hard to program in it. So it's kind of hard to know when do you actually know how to code with the language instead of just feeling like you know, but you don't really know. Also, this one, I'm not really sure if it's correct here, because I have polygon and I have matic. And I think this is the RPC for the matic. Yeah, people, I don't know a lot, but I think that's correct. If you're talking about C, just C, C++ is just C with objects. So it's pretty much the same thing. Yeah, but it's different, but almost the same. So this is not this one. So I think this is the testnet. I think I'm gonna remove this one. Yeah, this is the same as this, I think. So this is the testnet actually. And I don't know what they mean by mainnet here. Oh no, this is the mainnet. Oh no, the testnet. Yeah, testnet. Mumbai testnet. Rust has been getting a lot more popular. Definitely is something I'd like to look at in the future. You know what the syntax is like. I've got a very flexible remote job, so I'm mostly learning all day or watching streams. Good night. Good night, man. I really enjoyed the Rust. I did a course on it very briefly, and I really enjoyed the way that it works. But it seems like it's extremely difficult to learn, so it's something that is kind of like snowboarding, where the beginning is easy, and then to master it, it takes like a lifetime, I think. But I'm probably gonna learn it at some point as well, or try to learn it. So I'm gonna put polygon mainnet here as well. Hopefully it works. I think it's gonna work. I don't see any reason why it wouldn't. We just put the RPC there. Actually, I should put it like this. Oh, actually, I don't need the inferior stuff. And maybe that's the thing that I'm confused by, is that in some of these, you have the inferior. I think on the task nets, you put the inferior. But I wonder if I can do it with this RPC here. I think I'm just gonna deploy and see if it works. So my plan is to test everything on the Mumbai net, and then at the very end, once I think everything is working, after doing tests and all of this stuff, then I deploy to the Polygon mainnet. Yeah, so this file I think is okay. Or maybe I need the mnemonic as well. Yeah, I need to change the mnemonic. Forgot about that. So I think I deployed with ringby once. So I'm gonna do that with all the other ones as well. And obviously the mnemonic is on the environment variables. I don't wanna leak that because then my wallet can get hacked. And that's not good. Even though I don't have any money there. It's just annoying to have to create another one. Yeah, so now let me think. Oh, the other thing that I did here was he was using this function to get the mnemonic, which creates a text file with the accounts. But since I already have the account in the environment variable, I decided to go with this way here, which was the way that I had previously. But I wasn't using, I think no, I was using the mnemonic in the previous one as well. So I'm calling mnemonic, but I don't really know how to say this, but this thing here is pretty much the secret phrase from your wallet, and it allows you to sign the transactions when you're deploying. And in some cases, you don't need this. I'm not sure why it's being done like this now, but I remember the first times I did this, I used only the private key. So maybe it's not necessary to use the mnemonic. And I think it's more dangerous to use the mnemonic than the private key because I think the mnemonic allows you to recover the wallet anywhere, and the private key only allows you to get that specific instance of the wallet, but I'm not pretty sure as well. So now I have to think about this error I can just ignore because I was having this and it doesn't matter. It still works. So let me think. So I think I might open the scaffold if. I might go through the whole thing again as well. This Ethereum speedrun. And because I remember last time I stopped because I didn't have any money on my wallet, the fake money to test the contract apply. But now I have it because I've been getting the money on the faucets these previous days. So I might do that. And here I'm gonna change this to this file here. Well, I also don't have this file. Constants. I only have the other file, which this one is from the other tutorial, but I don't think I'm gonna do that because he was just doing this to store some information that I already had, so I don't think it's useful for me. Providers. And this scaffold, he also does. He also puts the information on that site that you can track blocks. I forgot the name. But then you need an API for that site, so I don't think I'm gonna use that as well. Yo, hello, what's up, man? I think by mainnet he means Ethereum mainnet here, and not just. Yeah, so I'm gonna have to open up, I think, the project from his, just to see. I'm gonna copy the file probably from the networks, and I'm also gonna see. So the biggest thing for me now is that on his project he has a bunch of code for this file here. I want to avoid that as much as possible. I want to have all the code for the connection in one file so it doesn't clouds up the other files. So I can focus more on the other logic, on the other files. Really? Oh, that's awesome, man. Bloomberg. It's a project that I'm doing for Buildspace. It's called Nights and Weekends. It's pretty much a challenge thing to... You have to build an application under 6 weekends, 6 weeks. And you can build whatever you want, but I decided to go with this one, which is something that I already built for another company. And because I don't know how much I can build in 6 weeks, I want to, in the worst case scenario, have something to show. So I decided to just improve the one that I have, and then if I have enough time, then I will probably choose to do something else or build extensions for this one. But the tricky thing is that I have no idea how hard it's gonna be to improve this, and that's something that I always had issue with, which is sometimes you get a problem, then you might get stuck on that problem for a long time, and there's really no way to tell if that's gonna happen or not. So that's the problem. The purpose of it is it's pretty much to just... I think their main goal is to help people, instead of being on the local host, to actually deploy projects and get real users on the project. That's the main goal. And then at the end, if you ship every week, if you make progress every week and you have something to show at the end, then they're going to invite you to San Francisco for a meeting or something like that, which I'm not going to be able to go because I don't have the visa, and the visa takes a long time to get it. But there's also going to be, I think, a couple of VCs or something like that. They're going to invest $25,000 on some projects if they like it. And you're also going to get an NFT that says that you completed this stuff, and it's going to be on their profile, which can increase your chances of getting hired on Web3. But even if you didn't gain anything, I think is very cool, this project that they're doing. Because it's just a way to get a group of people that all want to build stuff and putting pressure into them so they can build things and ship and maybe connect with each other. So I think it's really cool. But it's scary at the same time, because if you don't ship, then you obviously don't want to waste their time, or since they are betting on you, let's say. It's an NFT marketplace, but that's the thing. I'm trying to think about ideas to make it actually useful and not have just JPEGs on it. But it's very hard to come up with something that is relatively easy to do and actually has utility. So I'm not really sure what I'm gonna do out of it. But it's pretty much this thing here. And right now there's no NFTs, but... And this is on the Celo network. And that's what I'm trying to do here now, which is to change the networks, because for this one I did was part of a project of another company. Oh, now there is NFTs. I forgot that if I was logged out, it wouldn't show. I thought these NFTs were gone because I had to accept a pull request of someone that helped me fix some things. that were wrong on the project. And I thought that pull request would make it so that all the NFTs disappeared, because I don't remember if I redeployed the contracts or not. But pretty much here you can put the name, the description, an external URL for a site or something that you have that contains your NFT. Then you pick the file, you choose the price, it's gonna be on Silo, and you create the NFT, and then it's gonna be here, and then anyone can buy or relist. But I didn't spend a bunch of time on the market contract, because the marketplace contract, because it was very difficult to separate the logic of the NFTs and the marketplace contract and make it work. And that's another thing that I have to work on this time. I'm gonna do things completely different, and I'm also gonna study the OpenSea contracts for their NFT marketplace, which is Seaport, which I have here. But this one is extremely complex, so mine is gonna probably be a lot simpler than this. But they have multiple different contracts, and I think they have some stuff on assembly as well. It should be crazy hard to do. But I still don't know what I'm gonna do to make this. And I think I'm gonna change all the UI stuff here and add more things and make it similar to OpenSea, but try to think about something that can actually be useful instead of just JPEGs. No, lit code stays on the background now, because this stuff is more important to me, I think. But after I'm done with this stuff, I'm probably gonna go back to lit code to master that, yeah, data structures and algorithms as well.
Hello. So in this video, we're going to talk about how we connect, how we let our website, how we let our users to connect their wallet, whether it is a MetaMask or Dapper or Genesis or Safe or whatever it is, using a very interesting plugin called Web3 model. Okay. So you just have to, if you want to use this plugin, you just have to write it down like a yarn add Web3 model or npm install something like that, and boom, it is ready to start working on that project. Okay. So for this particular application, I just set up a very basic page, which is called a simple, which is the DAO page. And yeah, so basically you can see.
And this stuff here that I have to understand how it works. If hooks. So it's probably a good idea to study these libraries actually. Hopefully they probably have documentation. Oh, dot helpers. As far as I understand, this is the network you're gonna choose as the main one. Then you get the providers here, and this function connects the wallet using state. And the network options is one of the objects is sent through the Web3 model. And this is the thing that I'm not gonna be able to do, I think, which is the block explorer. But maybe it's possible, because this might be from the RPC link of the coin, specific coin. Local provider is static JSON RPC. What the hell is that? Oh, here, books. I think what I'm gonna do is watch these videos first, and then I'm going to put my project and the Ethereum scaffold thing on the side, and I'm gonna try to merge the two somehow to make the wallet connection stuff work. I think this is on this one. That's probably this file. Let's see what challenge 0 was. Or maybe it was this. I think I'll have to open. Ideally, I would open only one of them, because otherwise it gets too much. But I think I'm gonna have to open them both at the same time to see which ones contain the files of this code here.
See, we're just creating a button in this UI like this. We're creating a button, and clicking on this button will lead us to opening the MetaMask. And from there, MetaMask account, we're gonna connect use wallet. Okay. So for this application, I just built a very basic page called DAO. So let me open that page. DAO. Okay, so I think it is also open. So let's transfer it. Okay. So as you can see, there's nothing. It's just a plain simple page. And for the UI, just using the table, and the backend is all about the front end. I'm using Next.js. Okay. So let's add. So as you know now, you can see like if you want to add your Web3 model, just npm install it or
Oh, forgot to increase the volume. I think I'm gonna be here for a long time. Maybe let me put this timer here just so I'm aware of how much time has passed. So I think the plan is watch these videos first, and then to remember some stuff about Ethereum scaffold. Hopefully he explains the React code a little bit. I know that he doesn't like to explain things, and in some sense he's right, because at least that's the impression I got from this guy and the Patrick guy and the other, I think is Nether, something like that. Yeah, this guy here, Nether. I think they don't want people to just watch the tutorials and really don't understand anything about blockchain and then copy the stuff they did. They're doing this stuff because they want to actually learn, and that's the reason why they don't want to hand feed you everything. But it would be nice if he has some videos that at least explain kind of like the way that he thinks about it, or that he built this stuff, so I can understand better what is the connection of everything without having to spend a bunch of time digging into the source code and trying to capture the connection. And I think what I'm gonna do is, after I watch these videos, I'm gonna try to find the link between his project and mine, replace all the connections on my project to get the address, and to connect the MetaMask with the Polygon network. And after I have all of this, then I'm gonna test with the contract that I have to see if it works, at least the connection with the MetaMask. And then after that, I'm gonna start studying the OpenSea stuff and the other stuff. There's also this contract here, which is a marketplace, NFT marketplace contract, which is a lot more complex than what I did. So I'm gonna study this one as well. And I might study the UI first, because I think I'm gonna try to put a bunch of things on the UI that I wanna do, features that I wanna implement, and then I'm gonna build them one by one. I think that might make more sense, or make things easier to code as I go. You don't know about the blockchain stuff, but know a few things about React. Yeah, I know a few things about React as well, but I'm definitely not experienced on it. I know that there are a lot of more advanced things that people do, but the ones that I used the most was use state and use effect. But even those, I'm not pretty sure. Sometimes it can be difficult to know how to use them.
So I already did that, but I can do exactly like this. So this is applications we are gonna work on it. So yeah, so let's add our first
The
component.
difficult thing is that there are so many things, so many ways to do the same thing that it's kind of hard to decide from a designing standpoint which path to go. And that's where I'm kind of stuck now, trying to pick the best method to connect the user so it goes along well with all the other things that I want to do. And I still don't have the vision overall of the things I want to implement. I think at some point down the line, I want to try to implement machine learning models that create NFTs based on text data, kind of like GPT-3 or any other API like this. Those APIs I'm probably not going to be able to use because they're either not free or they're not allowing people to use them. But I think I can find other ones that are free and then I can incorporate on my thing.
Okay, so let's add a button, and basically I have this green button, so I'm going to use that button. But yeah, you can do anything whatever you want to do with this. This is just a component which I used it as a button. So the text is, let's say, connect wallet, yep. Connect wallet, connect wallet, and the other one thing is the on-click event handler on it. So for now, I'm just adding a simple console log message, console.log, just connect it. So yeah, so let's see how the page looks now.
It also feels weird to have a timeline to do things because I'm not used to that so far. Usually when I have a project, I just start the project and then see where it goes. And then sometimes I stop in the middle to do other thing or study other thing and then come back to it later. So having like you have 1 week to ship is kind of weird.
Yeah, it's connect to wallet, and that's simply a plain button, which is yeah. So now when I click on this button, as you can see, this is a message we can get yes connected. Oh, that's all. Okay. So now how things gonna work? Okay. So when we click on this Web3 model thing, you have to make the state persistent. Okay. You don't want to lose the state of anything. Okay. So for this, we're going to use a different kind of hook, which is called the userref. Okay. So let's import userref. Okay, which is coming directly from the React itself. Okay. If you want to read more about the useref, just go to YouTube videos, which I'm really fascinated about it. But for this video, just to understand what is actually useref is, just think about the use state. Okay. It's exactly like the use state, but the difference is you know about the use state. Okay. Whenever the state changes, it renders a page. Okay. Whenever you change something, it renders that particular. It renders it. But with useref, there's no rendering. Okay. Even if you change the state of it, you can change the state of it, but there's no render. Okay, and that's really cool of it. Okay, and now we have to, as I said, we are using the Web3 model, so let's import Web3 model as well. So let's import Web3 model as well. Okay, so I guess I'm import Web3 model from. Okay, I think I'm missing something. Okay, from Web3 model. Yeah. So I think I forget about it. So I think okay, just okay, I'm just yeah, that's correct. I guess that's correct. So that's very good. So if the initiate a variable from class case which is a MetaMask, and I hope so it is also for you as well. Okay, so now we initiate this Web3 model. But basically, you can see here as provided to providers actually. So providers is something which is actually help you to get data from your smart contracts. Okay, so providers is used for providers. So providers is used for to get data from smart contracts. While signer as a name signer is used to sign data, which is get, which is set the data. Okay, set the data to smart contracts. Okay, so this is the thing. Okay, but with signer can also do the providers like functionality. But yeah, for the distinction, for if you use the signer providers for updating the database, and for signers we get the for providers we get the data, and for signer we set the data as a name system. Okay, and for this project, as we are trying to communicate with ethers as well, so sorry, trying to communicate with Ethereum with the smart contract as well, and the basic another thing which you have to install is yarn add ethers. Okay, this is also a library which we are going to use it. Okay, just connect your web application with the Web3 code. This is a library of your choice. Okay, the ethers library. Okay, so let's import contract, not the contract, but the providers. Providers from ethers. Okay, so this is the thing which we are gonna use it. Okay, for connectivity purpose. So first, let's create a provider object from provider. Okay, let's create a provider object which is using this use ref. Okay, Web3 model thing. Okay, so Web3 model Web3 model connect. Okay, so this actually provides the thing. Okay, this actually provides the thing related to the wallet itself. Okay, what is the kind of things? What is the, okay, you can see we run this function. So connect function, which is over here, and you can see
Maybe I should share the ideas that I have as well. I'm just concerned that people are gonna install them. But the thing is, I don't really believe that the ideas are the things that are useful. But yeah, because it's more about the execution.
So we have to run this particular functions which actually initiates our wallet. Okay, now let's connect. Let's create an object which is called the Web3 provider thing. Yep, let's create a Web3 provider is equals to new providers. Yep, basically providers which is coming from the ethos. Okay, dot which kind of provider which we want. Okay, we need Web3 provider thing. Okay, so Web3 providers, and this is a way of connecting your MetaMask with your smart contract thing. It means like adding it to the layer of connectivity with your MetaMask things. So connect with your smart contract things. Okay, so let's constant ID as well. So have a record. Yeah. Okay, so now chain ID, again, this is a function which with the help of which we got the chain ID as well. This is a pretty cool function. Okay, and for the ring key, this ring key is the chain ID is not the chain ID for ring key is 4. If you want to check what is the chain ID for other networks, just go to the chainlist.org website and then you can see what is the other chain ID as well. Okay, so you can see this chain ID for this is this and this is this. So for different applications, the chain ID is there. Okay, but for ring key it's 4. Okay, for ring key it's 4. So if chain ID is not 4, you just alert it out. Okay, alert, yeah, use ring key. Okay. Okay, use ring network. We just throw an error as well. So throw new error as well. So if there's any error, we just throw it from here and ring not chain network. Ring is something like this. Okay, okay, and yeah, okay. And you can also do okay on which type you want the status. Okay, function. Okay, so duplicating binding network. Okay, refresh of each. How we connect. It's like setting up the text and the on click and basically pretty much for this project.
Yeah, this video is the one that I watched before streaming. It's really good. He uses Web3 as well, I think, the model, and he talks about the Ethereum, the scaffold stuff. So I might rewatch this one and try to make it work. But at first I think I'm gonna watch this one because I also watched this one, and I think this one explains the source code behind it. The main doubt that I'm having is how to put this on a file, a separate file, and then use this file in the other files, so I don't have to type a bunch of codes on every single file that I build to connect the user or to maintain the connection. And I wanna get the address on the other files, the address of the user, the wallet. Yeah, I think on the navigation I'm connecting the user, and the other ones I'm only using it to either get the address of the contracts through this use contract hook, or to get the address of the user, so I can filter here based on that. So that's the things that I have to figure out, I think. Now let me open the create as well. Yeah, I'm also using this perform actions here, which is going to be complicated, I think, to change. And on this file probably as well. Oh, here I'm not using. I'm using perform actions. That's the issue. I think I have to tackle them one at a time. This one is probably going to be the hardest, so I'm going to leave it for the last. Because I'm using perform actions, and I remember I didn't know really well what this function does. I think it's probably to change the state, but change the state of the address somehow, because it's being used like this, but I don't really understand exactly what's going on. And I'm probably gonna change the soul file as well, because when I change the smart contracts, I'm gonna have to change the way that I'm minting and that I'm asking for the approval. Because every time you put an NFT on a marketplace, you have to call this function, which is set approval for all, which is a function from the NFT contracts from Opus Appling that allows the marketplace to trade the NFTs in behalf of the user. And I think the issue here is that I'm overwhelming myself, I think, because I'm trying to think about everything at once. So I should probably just focus on the Explorer file or the navigation file first. I think I'm gonna focus on the navigation, but the issue is that that's why is a problem, because I'm not gonna be able. I wonder if I can go back, because I'm not gonna be able to run the application if the other files don't have any, are not working. Oh, I think I know a way to do it, so I can focus on one of them at a time. I'm not gonna do this. I'm just gonna leave the files like this. And what I'm gonna do is go here. Then I'm gonna comment these files out here. I think I'm gonna comment the routes. Doesn't work. Oh no, I'm forgetting this, I think. Yeah, there we go. Nice. Okay, so I'm gonna focus on the navigation first. I think that's the best approach. Once I fix the navigation, then I can focus on the other ones. That way I'm not gonna be thinking about multiple different things at the same time. Yeah, so here I was doing with the use contract kit to connect and destroy the wallet connection when you click the button, and render them conditionally based on the state of the address. And that's why I think it's better probably to figure out how to put everything on one file and then just call that file as a React hook, or to get the same variables. But the thing that I'm not really sure about as well is how do they do this structuring thing here, and when they're building the hooks, which is something I just know that it works like this, but I don't know how they do it on the file. So when you use state as well, for example, we're gonna have a variable and a function that are gonna be inside of the use state hook, but I'm not sure how the file works to capture both of those things. And that's the thing that I'm gonna have to think about, and think about a way to search for that, so that way I can design this file with that in mind, thinking about the information that I wanna export to the other files. And I think I'm gonna have to delete all of this stuff, but I'm kind of interested in these terms here because they are different, and big number is important, because I remember also that one thing that confused me a lot was the prices, how to structure the prices. Another thing that I realized that I didn't know before is that the reason why these coins have 10 to the 18 decimals is because it's better that way, because then you can make everything an integer. So instead of having floats, the decimals represent the floats. And that's why it's done that way, which makes a lot of sense. And that's why you don't have floats in Ethereum. It's just integers. But then you have to use the big number, and it's not clear to me the conversion. It's still very hard to understand how it works. Because you have to use parse ethers to convert when you're calling the contract methods, and when you're interacting, when you're making the bridge between front end and the smart contracts, you have to call the parse ether function, and with the big number in order to change the units. But if you have a specific network, it's not clear to me how the price is working inside of the contract, and what price I should display on the front end should be accurate in relationship to the price that it actually is. But I guess maybe that's done automatically with the RPC. That could be the case as well. And that's why it works, because even though you're just converting between Wei and ethers, depending on which RPC you're connected to, is gonna understand that the unit is equivalent to whatever the coin is. Hmm. So let me go back to the videos. Actually, I think I'm gonna delete all of this info here and I'm gonna redo everything from scratch because I have to think about. I think it's better if I start with nothing and then try to code the things that I actually need instead of having a bunch of this stuff and then trying to see which places I can erase and which places I should maintain. I think it's gonna be easier if I just start with the empty page. And this is really interesting as well. Another thing that I'm curious about and I will be studying as I do this is the MEV stuff, front running on the blockchain and the dark forest, how that works on when you're calling these functions and making transactions. If books. So I'm gonna search this thing here. Should probably search for documentation. Oh, it's not an official library from React. It's from Scaffold. Interesting. Thought it was a library from React itself. So this is what I'm gonna do. I'm gonna watch the videos and then I'm gonna put some music and explore this documentation. Oh, this is from Gary V. His NFT. Someone on Discord, a friend of mine on Discord, shared this with me. So it's probably good to look at this one as well, to see what kind of stuff he has here. They have here. Just see what I can do on my thing. The biggest issue is that a lot of these things are from business side. So Instagram page, Twitter, and all this stuff. And obviously I don't have that for mine. So maybe I'll create them. I'll code this stuff and then I'll create them later. This should look more professional. And also this privacy policy in terms of use. I think I might just copy from them or from someone else. But it doesn't look like there's a lot of features here. So I think the hardest part is going to be to integrate the backend with the front end and then to connect the graph to get the events from the blockchain. And the rest is more business stuff or CSS, which is quite very easy with HTML as well. And obviously the smart contracts are going to be really hard as well. So but maybe I'll close this stuff for now. Look at it later. React.
Web3 React library, and that is their homepage. It's written by Noah, and it is a very good library. And if you scroll down, you have the edit on sandbox. It gives you a few examples of how to connect to different wallets, which is pretty helpful. Check it out, yeah. And then for this video, we're gonna talk about what this for, how does it achieve this functionality, and then we're gonna run a few examples with like MetaMask, Wallet Connect, and Coinbase, and we're gonna do a connect, disconnect, and also how to send a transaction to a contract. Okay. And the goal of this video is you'll be able to use Web3 React in your React.js project and to connect to any wallet, and you'll be able to debug or customize your own connectors. And it runs a few examples to show you that it's actually working. So I don't know, like especially if you come from a backend development, and it's at least gonna save you some time. All right. So let's start. What's this for? Some background. We have Ethereum, we have nodes, and if you're Acme, you can run your own nodes, no problem. And we have wallets, which just stores your private key, right? And those, they talk to each other through the RPC API. And then on top of that, we have Ethers.js, Web3.js, which is like an abstraction layer of RPC API, and makes those communication easier and easy to understand and user-friendly. And on top of that, so then we have the Web3 React, which makes using Ethers.js or Web3.js or connect to those wallets easier in React.js projects. So I would say it's just for React.js projects, okay? And if you want to find an alternative, UseStep is another example. And I think they have pretty much the same functionality. I haven't checked it out yet, but yeah, take a look, and they have pretty cool sites too. So yeah, check it out. And yeah, so we're gonna briefly look at how did they achieve it and what's they actually doing behind the scene, right? We won't go through all the details of React.js or the code of their library, but just like briefly. So if you have any issue, you know where to find it and where to debug it. Just before I confuse you, we have the tab here called Web3 Test App. This one is our own app, and the page looks like this, okay? And sometimes I drag a window over, shows Web3 React 6. This one is a library that we're using. So that's the source code of the library, okay? So let's go back to our own app. In the app.js, we have the Web3 React provider, comes from the library. We wrap our code inside of it. So this basically just a context provider. And for all those components that's wrapped inside, we have access to the Web3 context it provides. And if you look at here on top here, and we have React Web3 React custom hook, which gives us those access to those contexts. Okay, and then over here, I'm just gonna quickly go through the code so you know that I wasn't lying, right? So you see there's a use Web3 React, which is the custom hook, returns the custom context. Oh, sorry, returns a React.js context, use the hook use context, right? And then this one returns a Web3 React context interface. That has connectors, library, chain ID, accounts, and also extends those functions, activate, arrow, or deactivate. And you may notice that we do have a library, a get library function here passed into here, right? And then the library takes a provider. Where does the provider come from? If you just follow their code, you'll see that in their manager, they have activate function, takes a connector, and the connector has the argument update function here. And then when you're trying to find the provider, it's like connector.getProvider. So each of them can have its, like each different connector can have its different providers. For example, if we go to the connector, injected connector, which is over here, okay? And then you can see that they have getProvider function, returns window.ethereum. And then the wallet connect, if we look at their connectors,
So it's pretty much the same thing that they're doing under the hood, but the reason why it's better is because they're using the hooks, so it maintains the context in the application and probably simplifies from having to do it manually.
They return their own wallet connect provider, okay, which is imported from here, okay, and the same for wallet link. And if you look at the source code here, and yeah, get provider, this provider comes from also window.ethereum.
Just a sec, I think. Let me see something. It's cleaning up the history. And okay.
So like it depends on the wallet, you get like different providers. Okay, so that's pretty much the code, and you can see like in each connector you have they implement the activate function, deactivate function, and etc. So yeah, they just like simplify those things for you. Okay, I know it's already gets so confusing, and it's hard to explain on the screen unless I take like an hour recording. Otherwise, it's easier for yourself just like go into the code and reason line by line. Pretty much it. So let's run some example. So the purpose of this is I want to show you it's actually working and it's working fine. So when you encounter some bug, you know there's something wrong with your code. Okay, so today is December 29th, 2021. So the latest version working, just so you know. And we're gonna do some comparison. Okay, first let's start with MetaMask, and that's how they connect to MetaMask. You just get the context, .activate, and put in the connector. We have all those connectors configured here, and if you want to take a look, and I'm gonna push the code to GitHub. So we have the injected connector, wallet link. Feel free to use all those like keys; they are free, so I don't care. So with MetaMask, this is called .activate, and I still want to show you that what actually under the hood they are calling this activate function, which in this line you see they activate those like connection to MetaMask. This is their code, just to be clear. So we go back here, just refresh just in case, and then we connect to MetaMask. They ask us to look at here, it's not connected right now, right? And then we put our password. You can see it's connected, and this is the account address or the wallet address. And then you see CDB here, exactly the same. If we click here, it's gonna print out those context. You see it has the functions and those variables. So basically, if you use Web3 React library, you can have this context like in all your components. So you don't have to passing those variables around or making like React.js context or whatever.
So let me see if I understand what he's talking about here. I think what he means by that is that I can, once you put the context in the beginning of the page, I can access the properties of the wallet at any point in the application. But I'm not sure how to do that. Maybe because in my mind you need to have a React hook on the page to access that. So maybe what it means is that you can just use the React hook, and then you can call this context here, and then just get access to these properties here in the same way that I would do with the contract kit from Silo. So I would get the account, which is gonna be equal to the address, and that's the stuff that I'm gonna use on the pages there. And in the navigation page, which is the one that I connect, I would have the activate and deactivate. Deactivate here and activate here. And then I would use this active variable here to check if the wallet is connected or not, to display the buttons depending on the condition. I think that's the way to do it, probably.
So after connected, here, we can disconnect, right? So here you see right now, this is the context. Once we click disconnect, to connect, all those contexts becomes undefined. Okay, but for MetaMask, it's a little bit different. If you see here, you're still connected, because for MetaMask, the user has to log out by themselves. You have no control over the disconnect function, because they believe that even you hold those public key or public address, you have no user. It's not authentication. It's basically just like the connection is more like I hold the public address. I hold the public address. So yeah, that's how it works. So the disconnect, if you see in their code, just for MetaMask, the disconnect function, it just remove all those listeners, nothing else. Okay. Then if I see this one is still connected, right? If I click this again, it won't ask me for password or anything. It's just gonna pick it up right away, because I'm gonna show you now. We have access to those contexts again. It's a special case for MetaMask, I would say. And you will see it is different for Wallet Connect and Coinbase. Now, if I disconnect, you'll see window.ethereum. There isn't much you can see here, but see, it still have the selected address. So it's still connected. It still keeps tracking of those addresses. And we could use MetaMask to do those like authentication, but that's out of scope of this video. We can do another video or just look it up. Okay. And let's back to vanilla JavaScript, this component. In vanilla JavaScript, we can write those code to connect to MetaMask, and it's gonna have exactly the same function. We use window.ethereum, the request, and do this. By the way, those are all in those like MetaMask documents. You can just look it up, and you'll find it. Then we get our account and we get our library. And the only thing here is when we get our account or library, it's in this component. So if we want to use this in other components, we have to find our own way to do that. And the Web3 React basically handle those things for you and make life easier. So just to prove that it's actually working, give it a refresh. Now I got nothing connected. If I click here, connect to MetaMask, it pops up. This side is our vanilla JavaScript. Doing the same thing. It's connected, and we see those accounts. And that's it. Okay, they're connected. So the next thing we're gonna do is to write to contracts. Okay. So I log up here and I give it a refresh. I want to connect with MetaMask here. Then write to contract. So we want to write a number to our smart contract. By the way, we have the test smart contract here. This is the address. This is the code. It's pretty much doing nothing. Just store a number and allow you to retrieve a number. Okay. This is the Etherscan. Current number is 17. When we click this button, it's going to run this function over here, write to contract. So that's pretty straightforward. That we're gonna get our contract. This function to get the contract. Again, no details here. We just read the code, and then you can pass in a library and account. And remember that with Web3 React, you have access to the library and account anywhere in any component. So you can do it anywhere you want. Then it's
Oh, that's what he means. Yeah, but what is this get contract thing? It's this file here, but yeah, maybe I will take a look at the repo. His repo to understand, but I guess he's talking about the Web3 React context. You're gonna have access to that. Yeah, use Web3 React to the whole page, I think, because you're creating the context, and under the hood is connecting to the window.ethereum. Interesting. So the way that he's probably doing is the same way that I'm doing there, but I'm using use contract hook to get the contracts, and he's actually passing the context inside of the function. That's probably the difference. Yeah, he's passing the account here, which is the address of the wallet that is connected. But maybe I can still do the way that I'm doing there, and but that's the thing. That's why it's so hard to change it, because I'm not really sure what design pattern to go with. That's the problem. Because I guess I probably both ways will work, but I want to be careful to not mix the two. That's the thing. Because the way that I'm doing here is now I was doing this differently for the silo because I was using the contract kit, but I think I'm gonna have to change this file here, I think, if I'm gonna use the context, because it's probably different. So instead of passing the API and the contract address, I'm gonna pass the context of the contract. But then, yeah, and then for each one I pass a different context, maybe. But maybe not. I don't think that makes a lot of sense. I think this is a different thing, actually. This get contract here, because this is using the context for the wallet and not the smart contracts from the application. So I think there's two different things. So I think I'll keep using this one for creating the abstraction of the smart contracts that I have, because every time I deploy it's just easier because it automatically goes into this page, the API and the address. Then I can use this hook to get the abstraction of the contract. But I'm not really sure if this is gonna hold. Yeah, the main issue here, I think, is making sure that this is gonna hold this state, and it's gonna work well with the Web3 model. Because I'm gonna create the contracts using this ethers.contract, and then I'm passing the address with provider.getSigner. So maybe I'll change this line here. So instead of using provider and creating a new object with Web3 provider, I will just use the context. Yeah, I think that's the difference. Because here I'm creating a new instance of the provider, and if I use the Web3 model thing, I can just use the same context, and that's more efficient, I think. So probably that's the difference. And then I use that context to get the address as well. So I think I'm gonna have to change this file as well. So this file and the navigation, I think I'm gonna close this one. Navigation, I think the navigation is gonna be the main one that I create the context first. And the other ones, I just get the address from the context. That's probably the best way to go. Maybe let me see on OpenSea as well, how they do it there. Because I want to have an idea of whether or not they keep this. They probably keep the navigation for all pages, but it makes a difference if you are gonna you're gonna remove the navigation on some pages, because then I have to think about the routing and the way that I'm gonna design the first file. Okay, so they have stats. I also want to do something like this on the navbar, where I have a bunch of different things. And so they have multiple different chains, domain names. Then they have categories of different NFTs. This is also interesting. So they have an explorer. And this one is also going to be really hard to create, I think. So they make a wallet like this, and then the profile here. So this profile, I'm pretty sure it's a Web2 thing. And I think it's gonna be a mix of Web2 and Web3. Or maybe not, maybe they just have the contract. I wonder how they do this stuff here. Very interesting. Yeah, so I should add a few. I think that's probably very easy to do, actually. The only difference, and the thing that might be a little bit harder, is adding this icons here, but I know how to do that. You just get from the font awesome or something like that, and you create a simple. It's not that hard, actually. And I think the only difference is adding this stuff here, this category, so I can filter through them later. This is gonna be really hard to do, actually. Creator earnings. The fee when a user resells an item you originally created. This is deducted from the final. I'm not gonna concern myself with trying to do all of these things now. I'm just taking a look at it, so it's easier for me to know which direction to take in the beginning with my stuff in order to improve it. I think this is what I was talking about before. Is I think the first thing I'm gonna do is change the navbar, and then add all of this stuff here. And then as I go, all that I'm gonna try to do is add the functionality for each thing that I added in the navbar first. And they have a bunch of things. Yeah, but this is the thing that I was talking about as well, which is kind of hard because Documentation, for example, is more of a business thing. And these links as well. So it's not really stuff that I think I can do. At least right now, maybe in the future. And see their documentation. It's another site entirely. And these small things that I think it really makes a difference. Because even though mine I think is relatively good, it doesn't feel like it's a real thing, because obviously it doesn't have all of these things. And that's what makes it the difference, is that this just feels too simple, even though it kind of looks nice with the color change here. And the reason why I think it feels like that is because I'm missing all of this stuff here. This business stuff with help center, documents, taxes, newsletter. So I think what I'm gonna do is incorporate most of these things here, but instead of putting these things like newsletter, docs, blog, taxes, I'm gonna think about new extensions to put here. And I think I'm gonna try to add things that are related to data analysis on the blockchain. And not necessarily only to NFTs, but could be just NFTs as well. Where I'm gonna put some tools to allow the user to see different trades, markets, and explore the blockchain to see what's going on under the hood. But my only concern is that this might be very difficult to do. So I might not be able to finish this in 6 weeks. That's the problem. Hmm. Oh, this is the one that I wanted to see. So I have the collection, properties, levels. Supply. Oh, this is really interesting. So they do the max supply based on the mapping of the NFT zone with the ID. So they probably have the cap on the struct when you construct the NFT item on the marketplace. I suspect that's what's happening here. So because it is what makes more sense. So I think they have a mapping of mappings. The first level of the mapping is the NFT address. The second level of the mapping is the item ID with the struct of each particular NFT with the properties of each one. Okay, so it seems like the navbar is persistent among all of them. And that's the thing I was trying to figure out. And let me click on one of them to see how it works. Which is also something that I don't have on mine. I can click here on the card and see what happens. So this, I'm gonna have to figure this out as well, because this looks a lot better, obviously. This page is gonna be really hard to do also. But I think that the logic they did here is pretty similar to the logic that I'm doing. where the navbar is fixed on all pages, and then you change the state based on the flow of navigation there with the functionality of buttons and the components. I think this is probably built in React as well, or some variation of React, like Next.js or something like that. And also the footer, I think, stays on, which is another thing that I have to add as well. And this one doesn't have the footer. Interesting. Also doesn't have the footer. I wonder how they do that. I guess they just put it manually on each component instead of putting it on the main one. Yeah, that's probably makes more sense. So depending on which page you put the footer as a component or not. And this one has it. Okay, enough of this. Let's go back to the tutorial.
You set override. You set the guess limit. It's to set it to a large number, and we can come back to the guess limit later. For MetaMask, so to put it simple, that MetaMask was able to calculate the guess limit, but so for some other wallets like Wallet Connect or Coinbase, they are not able to calculate the guess limit. So we need override here to set the guess limit. It all depends on which wallet you're using. Okay, and then it's gonna give us a response. We're gonna send an alert says, hey, we're gonna write this number to the contract. Okay, let's give it a try. We're connected, still connected. Write it. It's gonna charge us some gas, and then we confirm. We're writing number 4 to the contract. Okay, we'll give it a few seconds, and then you see it was 17, right? I refresh the page, go back here, retrieve it, it's still 17. Okay, it becomes 4. Okay, so we wrote the number to the smart contract using the Web3 React, and over here you can do. Here we call the store function, and here if you're doing it for NFT or you're doing for some other tokens, you can just write your own function, and again, other scope of this. So for vanilla JavaScript, how to write it? Here we also call the get contract, the same function here. This is vanilla. Same function here. Takes the library, takes the Web3 account. So exactly the same pattern as this one. The only difference is I only have access to those two library and accounts in this component. If I want to use it in other components, I might need to write my own custom hook to passing those contacts around. Right? And to show it's exactly the same thing. Go back here. I'm gonna lock it and clear everything. I'm gonna connect MetaMask on this side. By the way, what I did in our demo, I just keep those like library and accounts in the states. But for you, if you really want to write your own, you might want to write your own custom hook, and then you can use them in like your whole application. So write contract, and when I click confirm, it didn't give me a number. That's bad. Okay, you should give me. Oh, I should use plus here. And it just like, you can see, I should have passed here instead of a comma, okay? But it wrote a number, and we can remember it was 4, right? And then if we go back here, refresh it, it should be something else, a 0, okay? So it wrote a new number. If you look at the code here, you basically just get a random number, so nothing fancy. All right. So yeah, that's enough about MetaMask. So for MetaMask, we just need to know the disconnect function is a little bit funny, and they don't really disconnect it from here. So the user, even you see we got disconnected, the user has to disconnect themselves. Otherwise, I can connect either one because the information are stored in the window Ethereum. So I can connect it right away, and then we disconnect. Here, sorry, here I click it, I can connect it, right? And I don't need to disconnect. Okay, next example, wallet connect. You can see we have this function for wallet connect, and the first thing we need to be careful of is for me, I want to reset the wallet connect connector each time before the connection. The reason is I can get rid of this for now. And if you look at the wallet connect, it shows up, right? But if I close this, click it again, it won't show up again. It's maybe a bug or something that we could look into it later. But for now, the solution is just to reset it every time before you enter it, and it works well. So if I refresh now and then connect, fine. Connect, it's fine. Okay. And another thing with wallet connect is you can read up this page. It's about the security context. It needs to be HTTPS. And you saw it was fine here when I do localhost, but if I drag this window here, you see this is like connecting from the same network, but another computer. Now, if I do wallet connect, you can't really see what happened here, but you can see the whole page just froze. And if you find this issue, okay, let me refresh it. Okay, if you find this issue, the solution is go here, the package.json, and in your start script, add this line. Okay, again, the details can be read over here, and if you're interested, then let's restart observer. Save it first, restart observer.
Maybe you should do that. HTTPS equals true. First, I'm gonna try to do it without that. And the issue is that my script is different than his. Progress starts. I'm probably gonna get errors because I just deleted a bunch of stuff and changed, but yeah, that's the issue. Oh, that's another thing. Because I'm one level above the NFT marketplace. So I wonder if I should put the package.json on the main folder. And the reason why I did this is because I added this graph folder, which I'm gonna use later on to connect the graph with the application. And I'm probably gonna create a backend folder as well. I think I'm gonna try to do it with Django, depending on how much time I take to do the other stuff, because I have to ship as fast as possible. So I think I'm gonna leave it like this. The other difficult thing that is gonna be to integrate the backend with the front end. As far as I remember, you have to do some things in the Django file, the models or whatever it is, and then once you do those things that you have to do, you start from the Django server actually, and the Django server automatically starts the React one. As far as I remember, so that's gonna be a little bit hard to do. But I think for now I'm just gonna leave it like this. And then let's try to start. It's probably gonna fail the build because I changed the files, but whatever. I just wanna see if it works so I can add the stuff that he's talking about there. Just see if it's gonna run or if it's gonna break. Putting HTTPS equals true. And I think I'm gonna not talk anymore. And this headphone is really hot. It's bothering me. So I think I'm gonna put the other headphone. And it's also getting late here. And I'm gonna put some music on and just watch the tutorials and work on this quietly until it's morning again here. takes a long time the first time. Yeah, I'm gonna go to the bathroom. I'll be right back. When I come back, I'm not gonna use the microphone anymore. I'm just gonna follow the tutorials, listen to music, and do the stuff that I talked about previously. I'll be right back.
Okay, of course, this time you have to enable those like a security thing. Okay, now if I go back to the page, remember we need to add HTTPS here. Wallet Connect is working fine. So it's something like, if you find, it's not like Wallet Connect specific, it's those HTTPS thing. Okay, and after we got those things ready, then let's connect the wallet. Okay, for Wallet Connect, we are actually gonna use our phone. So I'm gonna have this over here so you can see what's going on. Oh, it's up here, make it a little bit smaller. Yeah, and when I click Wallet Connect, it shows me a, of course you have other like connect method. Right here, I'm just gonna show you the QR code. So on my phone, I'm gonna use MetaMask. It supports like many wallets that's on their official website. You can check it out. For me, I'm just gonna do the MetaMask. So 1 second, I'm gonna connect my phone to the computer, as you can see up here. All right, we have MetaMask, and then we click the scan icon on the right corner. We scan this. It asks us to connect. We click connect. Okay, and it's been connected. How do we know that? Same thing. We check the Web3 context, and you can see everything here. Okay, and then one thing about it is, if you go to application, local storage, it actually adds those things to local storage, so it's stay connected. What I mean is, if right now, if I want to write to the, I want to see my phone too. Okay. 1 second. I hope I can explain it clear. So right now, if I click over here, click the write to contract over here, you can see on my phone, it pops up this window, and I can reject it or confirm it. If I reject it, click here. See, I will know it like right away. It has been rejected. It's gonna throw an arrow. It's been rejected, and we can handle it like whatever we want. And if we do it again, pops up. This time we're gonna confirm it. Okay. So when we confirm it, and you can see same thing happened. We got a new random number, and we write the number to the contract. So we click OK, and you see this time it's 58. Okay. So go back here. Check the number 58. Okay. It's completed. Good. What's wrong with this one? Is there any issue with this one? Yes. So check here. If I click disconnect now, it's gonna get rid of all those local storage for me. I'll show you. So disconnect. Oh. No, it just removed one key, and that's good enough actually. So it's only removed the wallet connect key for me, and then we know it's no longer connected, right? So it's no longer connected. Everything's fine. And if we want to connect again, we have to scan the code again. So everything's fine so far. And I can scan the code and I can connect. Okay, everything's fine so far. The issue is, what if I did not click the disconnect? Go back up here, and we have this key over here. I did not click the disconnect. Let's do a refresh. Those WebSocket connection got lost, but we still keep the old wallet connect key here. So at this moment, if we click wallet connect, it won't pop up the window because it's connected automatically for us, and it shows our ID here. You can see. This time, I'm gonna write to contract again. You see on my phone, it pops up the confirmation window, but I'm going to click reject. Okay, I'm going to click reject. It's rejected on my phone, but you can see nothing happened on this window because this key was not refreshed. It's not refreshed to a new one. So our WebSocket connection got messed up. That's what happened. And because we know exactly what happened, we could come up with any solution that we like to. And just as a temporary solution, what I did is on the window load, I cleared the local storage. You can come up with a better solution, and you can just like clear the exact key that you want, and it's all up to you. I'm just showing you that it works. Okay, so we can save this. Go back here to refresh, and you can see the local storage is empty. Now, wallet connect again. Connect to wallet. I click connect. Everything's fine. I'm gonna do a refresh. Okay, I'm gonna do a refresh. And the connect is gonna ask me to connect it again, so that the old key is not stored. If I connect it again and I send a request, to write to the contract. You see over here, and then I'm going to click reject. If I click reject, the communication is working, right? So that is another issue that we want to solve. Yeah, issue with HTTP and issue with communication. Those are two issues. Okay. Then, what about vanilla JavaScript? Let's go back here, look at the vanilla JavaScript code. And I won't go through the detailed code of it, but it's doing the same thing. Okay, it's doing the same thing as a library. It's gonna as a Web3 React library. It creates a library, it gets an account, it sets to the state, and then we have access to it. So I'm just gonna quickly show you it's working, and it works the same way. Okay, so if I connect to the wallet, and this time the same thing, and I can write to the contract. And I don't want to do it here anymore, but then I'm gonna reject it. You can see it's being rejected. Okay, so everything's fine so far. And then you see we have this in the application, and then when I click disconnect, it removes it for me. The reason is, in our disconnect function, we actually call the wallet provider .disconnect. But oh yeah, it's the same. Sorry. And in the wallet connector over here, the wallet connect connector, in their disconnect function, deactivate, they call the same thing. So that's why they also just remove those key for us. Okay, it's a thing. Okay, now it's okay, now the last one is Coinbase. Okay, and so it's the same thing here. That is the Web3 React code for connect to the Coinbase, and it uses a wallet link. And when I click here, it shows me the QR code, and I scan it. I mean, you see my account over here, and I can send the contract. It's gonna show up here, and it's the same thing. I'm gonna confirm this time, and then it writes 35 to Etherscan. So if I lost that, Etherscan, repeat here, and contract. I'm gonna copy this address over here. Remember, it was 35, right? And here we got 35, so it's successful. And you can see the disconnect function is a little bit different. So for example, if I disconnect here from Web3 React, everything's still here. So when I click connect, I connect back. I disconnect, connect without anything. And say for example, the user wants to change to another wallet to do a refresh. Oh, sorry, I can get rid of that. I should get rid of. I'm gonna get rid of this one for now. Okay, and now we do a refresh. So that's a problem with Coinbase. So when I connect, I do connect again. Not with Coinbase, basically the way it's disconnect. So now I disconnect, I can connect back. I disconnect, I can connect back. Like, there's no way for us to disconnect. Even when we refresh a page, the storage is still here. We can disconnect. And the user might think, hey, what do I close the browser? Right? And I go to the same thing, HTTP. Yes. And check here. The local storage is still here. Then they can connect. There's no way for them to log out, which is bad. That's why I also like this code, the local storage clear code in our code here. Then when the user refresh, they're able to log out completely. You see this local storage disappeared and they have to connect again. But we could improve that in our vanilla code. See, I don't have this one. I comment out this one, and I'm going to connect to Coinbase, the same thing. And then when I click disconnect, it's clear it for me. The reason is for the vanilla code that the disconnect function is calling wallet link provider.close, which it's gonna do the cleaning up for us. And in the library, they just remove the listener when they deactivate. So it's up to you that you could even add this provider close. This is gonna clean up things for you, or just like what I did over here, that you could clear the local storage every time, as long as you know what side effects it has, right? As long as other part of your application does not rely on it. And yeah, that's pretty much it. And I hope this helps, because it takes me about like 1 day or two to figure out those things. And now I think you should be able to modify the library to meet your needs. And I just show you that it works for 3 wallets, and it also works for like the rest of the wallets. So yeah, have fun. And if you have any question, let me know. And I know it's kind of like my first YouTube video, so it's not explaining very well. So let me know. And if there's anything about React.js I wasn't clear or I wasn't saying it correctly, also please comment it below, and I would love to hear them. Yeah, that's it. Thank you.
This one goes out to the builders, the innovators, the makers, thinking about making something on Web3, some kind of crazy decentralized thing that I don't even understand. So you've got the basics down with ETH build, but now it's time to build a product. Let's get started. It's today, like now, okay? So let's start with Scaffold ETH. It's not a product itself, but more like a combination of a stack of a lot of other great products. Scaffold ETH's superpower is being able to work on a smart contract while you work on your front end. There's this tight iteration loop between creating your smart contract logic and building the front end functionality. So let's just dive in. Let's just go to the repo. If you Google for Scaffold ETH, you're gonna find all these tutorials and quick starts, but let's look at the smart contract sandbox. Basically, we're just gonna clone down the master branch of Scaffold ETH and CDN and Yarn install. You're going to get these no JIP errors. Just ignore those at first. Do a yarn start. It's going to bring up your front end on localhost 3000, but don't get too excited. Don't get distracted. We need another terminal window to do a yarn run chain. That'll bring up our blockchain. Now we need a third terminal window to do a yarn run deploy. So that's going to compile and deploy our contract and then publish it into the front end. So now we've got 3 terminal windows. We've got our app coming up and the contract addresses, right? Let's look at the source code. So you have 2 main packages. There's a builder package. That's where your smart contract is going to be. And there's the React app package. And that's where your front end is going to be. The app.js has all sorts of stuff like providers and scaffolding and handy components. We're going to use this contract component that talks to our contract. Let's really poke at it. So let's try setting the purpose. Let's see what happens when we hit go here. Oh, no, doesn't fail. We don't have any gas. Okay, so first thing we need to do is copy our address, paste it into the faucet, and grab a grip of gas. Now we should be able to make that transaction. All right, it's working. We're getting rad. All right, now this is working. We can iterate. We've got our contract. We've got our front end. Let's turn it up. We're going to do yarn run watch, and that's going to be speed mode. Basically, anytime we make a change to our contract, it's going to automatically compile and deploy that. Let's try setting this guy as the owner. Boom, he's the owner. 1B49. All right, now let's put some rules in here. So we want to set it up so only the owner can call set purpose. How are we going to test it? Well, I bet he can set it. Yep. Okay, then we grab another one over here. Burger wallet. Let's try 313. He gets some money from the faucet. He tries. He can't though, right? Yep. No, doesn't work. Okay, this is programmable money. Let's make it payable. Let's make sure that the person sends in 0.001 ether, or let's atomically reverse. So basically, I have to be the owner and I have to pay. Doing cool stuff. It's gonna fail. Okay, now I'm paying the big bucks. Put in 0.001 ETH. 10 to the negative. 10 to the 18. Turn it into hex. Console log. Sorry, scaffold is super handy. You've got hooks and components. Things you're gonna reuse all the time. Use balance. Use gas price. Use contract reader. Use block number. There's also a bunch of handy components you're gonna use. You need to copy that address. Boom, it's copied. You need ENS. There it is. You need to paste in an address and see the block E, or maybe you need to Austin Griffith.eth me something. Maybe $100. Turn it into ETH. It's 0.4405. Remember, it's about that contract iteration, that tight loop. Scaffold ETH. Check it out. Happy Bowtie Friday. Hearts, hearts, hearts. Good morning, happy Bowtie Friday. Today I'm looking at Scaffold ETH. So Scaffold ETH is a repo that I have that is for quick product iterations and tinkering. So if you're interested in tinkering with Ethereum or building a dApp, this is a cool place to start. So I'm gonna just get the clone started. So I'm gonna clone the repo down to my new dApp, or rad new dApp, okay? And I'm gonna cd into rad new dApp. And I'm gonna start the installation process. So this may not work perfectly for you on a different machine. Remember, you'll need Node.js, whether you have Windows or Mac. You'll need Git, Windows or Mac, and you'll need Yarn, Windows or Mac. I've ran through this a couple times on both Mac and Windows, and those three things at those versions seem to work pretty well. So while this thing is installing, let's go ahead and bring up our favorite code editor and just look at the file system. So there's three packages. You'll have Bidler, contracts, and your React app. So the Bidler contracts folder is where all your main contracts are stored. And this is something you want to pay close attention to. All right, so our smart contract is located right there. And then our app is located right here. And let's go get that started. So that's the next thing on the list, is to do a yarn start. And that's going to bring up our React development server. And that is powered by this app.js here, and also this smart contract wallet.js here. Rad. Okay, so lots of links here if you want to go read more about how everything gets started, but basically we're going to bring up our own development server, we're going to bring up our own blockchain, and we're going to be able to edit our smart contract live over here, and we're going to be able to see it reload in our app. And that's the key to Scaffold ETH, is just getting this like hackathon stack up and running quickly and be able to iterate on prototypes and figure out if maybe this idea is a good idea or not, and just kind of like poke at stuff on chain. Okay, here comes our app, and it is up, and it tells us that we've got the first two things taken care of. We've done a yarn start, but I don't have a yarn run chain yet, so we'll do that next thing. Yarn run chain brings up the Bidler EVM. You could do yarn run node also, but it basically starts our local blockchain. And now if we reload this, it should check that off the list. It should detect that we have, we'll see down here in the bottom right, yep, our providers, and it's on block 0, and it's up. So the next thing we need to do, so we'll create another terminal. So we've got our first terminal is our app, our second terminal is our chain, third terminal, we'll go to rad new dApp, and we will do a yarn run deploy. Actually, let's do a yarn run compile just to show that they're separate. So I can compile my contract with yarn run compile, and it's going to download the compiler and get everything ready and compile to artifacts, to my artifacts, but that stays in Bidler. If I do a yarn run deploy, if I could spell it, woo-wee, that's going to do the compile, but it's also going to deploy our artifacts. It's going to do the compile, it's going to deploy our contract, our bytecode, to our test chain, but it's also going to publish our artifacts into our front end. Look at that, look at that, look at that. Okay, so now we've got our smart contract wallet, and it's deployed here, and we see that there. And if we go look at this, it says fix the spelling error. Okay, let's go fix the spelling error. smart contract wallet, and I'm gonna hit save, and we'll go back over here and do a yarn run deploy, and compiling Solidity, deploying bytecode, publishing artifacts, and then our front end reloads with a new contract that's correctly spelled. Okay, let's do one other thing. Let's do yarn run watch. I'm just gonna have that thing on autopilot, so anytime I go over here and change this, let's add some force to it, some exclamation. Then it's going to detect that my smart contract changed. It's going to run through the full gamut of pushing it out to my app, and we should see a hot reload here in a second once everything is done with our new contract with exclamation points. All right, here we go. What's next on the list? We need to send some test ether to our address. Okay, so our address is this account up here, and it's a burner address, right? If you just land on this, you're gonna get a new address, right? If I open up another one, I'm gonna get another address, right? So let's just copy that burner address and let's paste it into our faucet down here below, and a transaction is sent, and it's gonna send us like 0.01 test ether. If we click this, we can see, 0.01, which comes out to 207 today if you're a follower of the price. Okay, now, what's next? Deposit funds. Okay, here we go. Deposit. Look at that. I'm depositing funds into my smart contract. And that works because we have a payable fallback function. And we can also see, if I hit deposit over here, look at this, a console log from our blockchain telling us that A0DE, this homie right here, just deposited some funds. What? A console log? That is red. Okay, cool. Now let's set the owner of our contract to our address. We'll go right over here. We'll hit the edit button. We'll hit enter, fire a transaction. Now we're the owner. Wait, what? Okay, so now that's when the tutorial gets a little wild and it says, yikes, anyone can take ownership of your contract. That's when you'll probably want to come back here and start looking at your code and figuring out your Solidity. And there's a lot of great links here to the repo, to the Ethereum docs, to Solidity docs, to Bither docs. At me, bro, anytime, hit me up. If you want to see what this looks like with our MetaMask, let's see. There we go. So I can log in as me also. Just remember, check that network. That network needs to be on localhost, and you'll see that change down here. Awesome. Cool. Check it out. Bang on it. Play around with it. Thanks for coming along. Check out Scaffold ETH. Give me lots of feedback. What we want is for lots of external developers to come see this and say, ooh, I want to build something cool on Ethereum. Awesome. Let's do that. Happy Bowtie Friday. Thank you. Scaffold ETH. Check it out. Happy Bowtie Friday. I'm Austin Griffith.
This is the source code that he was talking about earlier in that video, where he talks about the local storage, because this is the Web3 model source code, and apparently he's using that to clear the cache in the Ethereum in this project here. I think what I'm gonna do is watch the videos about this project first, and then I'm gonna do npm start here, and I'm gonna spend a lot of time trying to understand this project first, because I don't understand really well how everything works on this one. And I'm gonna see both the functionality and the code, so I understand how everything connects together. And then after I do that, I'm gonna try to integrate the parts that I think are gonna be useful from this one into mine. I think that's the best approach to go. The biggest challenge I'm having so far is deciding what stuff I'm gonna put here, and because it's hard to decide with what I'm gonna begin with. That's the biggest problem, because I already have a bunch of code on this one and don't want to lose all the code that I did. And at the same time, I feel like it's probably not the best to start from scratch, but maybe it's better to start from scratch and just try to integrate this stuff that I'm seeing here. Yeah, this is the thing that I was looking at before as well. So he uses the Web3 model and then creates the connection like this. And this is the part that is hard to understand. So maybe I should study the source, not the source, the documentation of the Web3 model, to understand more which parameters I'm gonna put here for my case, which is Polygon, and maybe some other chains as well. And the tough thing is that everything is connected, so if you start reading one part, it leads to a bunch of different parts, and that's why it's kind of hard to know what's going on. That's why I think it's better to understand this project first, really in depth, try to get a good grasp of how everything is connected. I'm also starting to think about changing the design, the entire design of the way that I did this, to be more like this. But the only difference here is the issue is that I have to have folders to separate the components, because they have CSS files for each one, and his doesn't have CSS because it's probably using Bootstrap for the CSS. And this themes here is also interesting to put a dark mode and a light mode, which I think I might try to implement as well on my stuff. And also have to understand what's this scripts here. And the biggest difference, which I don't like the way that this was done, is this utils file here. I think that's what I'm gonna change, where I have the functionality to interact with the smart contracts. I think those folders I'm gonna put on the scripts file. I think it makes more sense. And maybe rename them as well, because it's kind of confusing the way that I did it here. Let's see what else. I was trying to see where the stuff comes from there. The connections, networks. I don't know what this file. Also, it is the constants. So it's correct. Yeah, but he gets the... So maybe I got this file from somewhere else because I'm getting alchemy key here. It's not supposed to be there. I'm gonna watch the videos and then I'm gonna study this project here very in depth, and then I'm gonna try to incorporate this stuff here. So hopefully I can make the connection by change the connection from the Silo network to the Polygon and connect the wallet to the site.
But today we're looking at scaffold ETH and how we brought the graph in. So now it's a lot easier to display your front end and parse events using the graph in scaffold ETH. And I want to run through that real quick just as kind of a speed run. Too long didn't read on how to do that. So basically, just a quick intro to scaffold ETH. It's a dApp building toolkit kit. Basically, it's hard hat and React and a bunch of components and hooks that I put together to make it easier. And the superpower is about being able to edit your contracts and your front end at the same time and kind of build things in parallel, and you learn a lot from doing that. So here we go. Let's get this thing going. So the first thing you do is clone down scaffold ETH. I've done that into your next step. Then you'll do a yarn install, and that's going to install all the packages. It'll take a little while. Then when you're ready, you can do a yarn start, and that's going to bring up your React front end. We'll get that at localhost 3000. Then we need a new terminal, and we'll do a yarn chain. That's going to fire up your hard hat node and also give you a bunch of accounts with money in them. We'll use those for the faucet. And finally, the third thing is a yarn deploy. So that's going to compile your contract. Scaffold ETH comes with a your contract. It's kind of like a placeholder contract. It'll compile that. it will deploy that to your hard hat node. Then it'll take the artifacts, the address and the API, and it'll inject that into the front end. So when we do a yarn deploy here, watch this contract right here. It's 5FBD, and now it's something else. There we go. So we get a new contract every time. And if we are editing our Solidity, let's go look at our let's go look at it right here real quick. Here's our contract. Programming money. Oh, whoops, I didn't mean to do that. Yarn deploy. What we'll see is this value is going to change, right? We're going to get a new contract that's going to be deployed with a different purpose. There we go. Okay, cool. So this is basically the scaffold ETH setup. You'll spend a lot of time kind of working on your contract here, and then editing your front end in the React app here. Lots of tasty hooks there, help you out, like get balance, contract reader hooks, ENS, like a lot of stuff that you find yourself using in every build. There are these nice handy components. Here's one of my favorites. You always need to take in an address when you're building an adapt, right? Wouldn't it be nice if there was a nice input field that did ENS resolution and did a blocky preview and even boop boop boop, it's a QR code scanner. Which camera is it? I don't even know. But yeah, that's a very common thing. So with it just built into Scaffold ETH, and it helps you build prototypes and products quicker. What we're looking at though is once I have this and I'm able to, oops, we're gonna have to, MetaMask, come on, no, let's log out. Let's get out of there. Let's use this burner. So you when you land on Scaffold ETH, you get a burner wallet right away. You can head to the faucet and give it some funds. Now I have enough for gas, and I can say hello world on my contract. And there we go. We can start to another one. We can kind of just set this purpose, right? Writing is very expensive. Reading is super cheap. We've got our purpose getting set. We can even use this example UI, right? This too. This will also talk to your contract. There's a lot of like UI examples, but this is what we're looking at here. Basically, once you start building your front end, you'll find that you need to trigger events in your smart contract. Whatever happens, think of it if your contract was a decentralized bank and you were wanting to read more than just someone's balance, right? Okay, fine. Alice's balance is this, Bob's balance is this, but what if we want to show Alice like her whole withdrawals and deposits, like the whole balance sheet and how you got to this balance? You would want to trigger events on every deposit and withdraw, and you'd want to show those here. Well, after a while, you end up having to parse the chain way back, and these events take a long time. Like if I go to support.buildguild right now and I look at the activity, these are events. And look at that. Look at them come streaming in, right? You can imagine if there were thousands of those, this front end would just fall apart, and that's what happens. So what you need is a middleware layer, which is what the graph does, which brings basically kind of this Postgres database in the middle. It parses your events, and then you can kind of like GraphQL like query that database. So it's just going to end up making your front end a lot easier and making your life a lot better when you have to query some complex thing. You're going to be able to just say, hey, give me that thing that's referenced to that thing. You can make typical kind of classic database calls, and it's a lot easier to present and digest data that way. Okay, so let's see. Now we have our basic typical Scaffold ETH setup. We've got our app at localhost 3000. We've gone through the spiel. We've got our chain up. Now it's time to basically kind of make the change from event parsing over to the subgraph. So there's this new subgraph tab. Once you have your app up, check out this, I guess it's that direction, check out the subgraph tab. and it kind of gives you the same hint. Hey, you've been using use event listeners. Let's do this a little differently. So you're going to need Docker. You can probably install that with Brew, or you can install it from their website. But basically, Docker is like a containerization service. It helps. It kind of like infrastructure. Your infrastructure basically is in your code, which is really cool. But for us, it's going to help us set up a whole Postgres database, and I don't want to F with that. No one wants to F with that. Here we go. Okay, so in case you have some data that's pre-existing in that in your app directory, you want to clear that out. That goes to that Docker folder kind of up here. You'll notice a new Docker folder in Scaffold ETH. And also there's this new subgraph folder, which we'll tackle in a second. But so we cleaned out any old data, and now we're going to yarn graph run node. Shout out to Adam. He did all this work. Thank you, Adam, for doing that. You saved us. We probably wouldn't have this if Adam wouldn't have done that. So thanks to him for putting this together. But what we're waiting for here is for our Docker node to spin up. And then once it spins up, we're waiting for some, we're going to need a new terminal. Yep. We're waiting for, it's like, what is it? Something about WebSockets or something. There it is. Yeah. So now it's up. Then we grab the next command is create local. This will work, and it will only work once.
I'm actually seriously considering doing everything from scratch again. It might be better than trying to incorporate the code that I already have. Because it shouldn't be that difficult to build the functions, now that I think about it. And if I'm gonna put this stuff with Docker and all the other stuff, it might be better to start with a clean thing. Or maybe I just copy some components into it. Because it's very overwhelming, the amount of stuff that I have to think about at the same time. And I'm having a lot of trouble with that. So yeah, maybe after I study the thing, or maybe I can try to start from the beginning on a different folder, and then once I have the other folder, incorporate the old project into the new one. So maybe just create the connection first on a clean project without any other files, and then try to add the components into the new one. But I'm not sure if that's worth it or not.
So if you're running it and it's failing, and then you run it again and it works, and then you run it again and it fails, you may miss the fact that it worked. But pay attention, this will only run once, and if you run it again, it's going to fail. I mean, you can run it again, but it's just not going to work. Okay, then the next thing, then finally you do this graph ship local. So let's take a look at our subgraph folder. In particular, there's a template for your subgraph. So there's this template here that's going to plug in whatever contract address. Just like how Scaffold ETH likes to handle things for you, when you do that deployment, it's going to grab your deployed contract address, put it in here, and generate the subgraph.yaml file. And I believe we can fire that off here. Yarn graph ship local. Yarn graph ship local. There we go. This new subgraph is generated. Cool. Awesome. So that template, we'll dive in and look at that in a second. But there we go. Now we've deployed it, and I think actually, there we go. All right, we can actually start doing, let's see, if we wanted to look. So what it's doing right now is it's just tracking these purposes that are getting set up using the set purpose that Scaffold ETH uses out of the box. Let's just say, what if we wanted like the most recent person that submitted a purpose, something like that, maybe. Yeah, there we go. There would be their address, right? And then, or maybe you wanted like the oldest one. You could probably do something like that. There we go. So this is like a little sandbox that lets you play around with making the correct GraphQL query. Once you have the query and you like the way it's looking, you can get into your app and basically build out your front end using this pre-populated object that's just way better than having to sit there and use a hook and parse events. So let's back up a little bit and look at what this YAML file does. In particular, you'll have these entities, and for these, you're going to need to set up this schema. So there's this schema here that tells you kind of like what entities you have and what data types they have within them. And you'll notice this is really cool. Look at this. So basically this, the sender's purposes. So for any given sender, we could check their purposes. Let's do that. Let's do that. So given this sender, I bet we can do, this is going to be really weird, but we're querying purposes for the first one, and then we're getting the sender of those. And now I bet I can do purposes here. Oh, well, except for that. And what does it do? Does it just, let's see, I think it tries to help me. Yeah, and then it's going to give me the ID, or can I just do purpose? There we go. This is cool. So basically I got who is the person who has set it the most recently. Given their address, can we look up all of their given purposes? For some reason, you can see here that you can put together some complex and exotic calls and get just the data you need, and things are kind of like referenced. There's a lot of this kind of magic here where material that or entities that reference each other are sort of kind of like automatically packed in here. Cool. So you've got your template, you've got your entities. Those entities have the schema. They can be referencing each other. And then down here, we set up our event handlers. So given our contract, let's go look at our contract real quick. It triggers the set purpose event. So given this set purpose event, if we look back here, we're going to say we're going to set up a handler. So we want to handle the set purpose event, and that handler is going to be in this other file here, this mapping file. And this is the most complicated file. It'll take you a little bit to grok. There's some weird stuff there. You have to remember to get this just right. But basically, you're going to import those entities. You're going to import the schema, and then we will basically trigger this handler. So this handle runs when each event happens. So basically it's listening for events, and it'll go back all the way through the chain and parse all the events, but anytime it gets an event, it's going to run this code. And we can see what we can kind of see what it's doing here. Basically it's going to get the sender's address here, right? And using that sender's address, we're going to check to see if the sender already exists in the database. We're going to do a load. If it's null, then we're just going to kind of create a new sender and set the parts of the entity, right? There's a sender.address and there's a sender.purpose, right? We're going to set those things here. And Adam, just as an example, did purpose count +1. So it basically like increments this person's purpose count, just showing you that you could get in here and say purpose count and find out how many purposes that person has set. There we go, is 3. It showing you that it runs this each time, and with each event parsed, even if this sender already exists, we're just going to increment that. Not sure if you would use that exactly like that, but just kind of like showing off how this is going to work. Then we save our purpose. We create a new purpose entity, and then at the very end we save those. And there's a couple different forks on scaffold ETH. There's a lot of good examples of how this works. You'll want to kind of look at a couple other mappings because there's some weird intricacies here, but basically you have the template that's gonna give you where your handlers are. You set up your handlers, and your handlers end up initiating these sort of data types, these entities. Once you have all that, you can basically do, instead of doing this whole setup, you can just do this yarn deploy and graph. So let's say, let's go back to my contract now, and let's just say our purpose is programming, our starting purpose is programming for some reason. Instead of doing a yarn deploy and just shipping my contract, I'm going to do yarn deploy and graph. And that is going to compile my contract. It's going to ship it off to the hard hat node. It's going to take my artifacts and it's going to inject them into the front end, but it's also going to take my address and generate my subgraph YAML, and it's going to populate the database and fire it up. So now everything is ready. We've got our new contract that's just programming for some reason. But now as we set, change things like purpose, like here, let's go change one thing. Let's set it up so in the mapping, instead of adding 1, it adds 2 for some reason. So your first one gives you 1, and then every subsequent one adds 2 to this purpose count for some reason. I don't know why. And let's go ahead and ship that, right? And in this case, I don't need to redeploy my contract, but I'm assuming that you're kind of making contract changes and making graph changes and kind of like manipulating things all at once. In this case, I could have just run this, but we're going to run the full deploy and graph, and that's going to give us a fresh copy. And then let's set the purpose 1, 2, 3.
Also proud member of the Build Guild. So joining here with me is the boss himself, Austin Griffith, the creator of Scaffold ETH, and it's great to have the man, the myth, the legend here himself. So without further ado, the floor is yours.
What's up, Shannon? Thanks a lot, man. Yeah, Build Guild. Woo, good chill. We'll get to the Build Guild here in a little bit. Yeah, if it's cool with everybody, I'm just gonna dive in and get going. The goal today is just to put together a kind of speed run through scaffold ETH, and it's really an Ethereum speed run, but I'm kind of focusing on scaffold ETH to show you builders out there just kind of like how to get started, how to get going, and then just like once you know Solidity, it's a whole tour of duty to learn all the other different intricacies and gotchas about Ethereum and building on top of it. So I'm watching the chat here. Ooh, it's probably a YouTube chat, isn't it? I should probably let me see if I can pull that up and mute it just so I can keep an eye on the chat there.
Actually, Griffith, we've muted the YouTube chat.
Okay, so there is no chat. If you want to chat, if you want to talk to me, reach out to @Austin Griffith. I'm Austin Griffith on all the socials. I look like a little here. Let me just start screen sharing. We'll get right into it. Here we go. Middle roll. That one's for Shannon. I think we invented that.
Let's kick off with our first talk of the day. I want to welcome Austin, who's going to dig right into scaffold ETH. So Austin, welcome.
Thanks for having me, Kartik. Excited to do a whole day of dev tools. This is really neat. There's a lot of gigabrains that you guys have amassed here together to talk about tools and Ethereum. Like you said, I will dive right in. I'm a builder on Ethereum, and I work on this tool called Scaffold ETH with a great community of folks. But just to zoom out just a little bit, this is a great landing spot. Ethereum.org is a great place to go for a big picture, learn the how and the why. And if you get in here for developers, there's the tools that a lot of the tools that we're going to see today are here listed somewhere on this, so you can get started. And I'm going to be talking about Scaffold ETH, but Scaffold ETH is just a collection of a lot of other tools like Hard Hat and Ethers. So we'll hear from them later today too. So let me jump into Scaffold ETH. So Scaffold ETH is it's a dApp template. I found that like creating my whole stack took a lot of time at every hackathon. So Scaffold ETH is a template where you have everything freestanding and working right out of the box, and you can kind of tinker and learn and go from there. And what I mean by that, let's just go ahead and get it started here. So I've got my front end. So if you go to, I don't know, let's Google Scaffold ETH there. If you Google Scaffold ETH, it's going to drop you right into the repo here, and you can follow this. Basically, you will need like Node and Yarn and Git, and that can take some time to set up. Make sure you get the right yarn if you're on Linux. I go through that a lot with developers, where it's just getting the environment right takes a little time. Then you'll clone down Scaffold ETH, yarn install, and yarn chain. And yarn chain fires up Hard Hat. So it has a Hard Hat node on the back end that has a bunch of wallets for us that are loaded up with ETH. And then you'll yarn start, and that will bring up your dev server, your React server, your front end. So we kind of have a back end and a front end. And then the last step is to yarn deploy. And what that's going to do is take this stock contract, this kind of like example contract for you, and it's going to deploy it to the front end. If I bring this down, let's see, I don't even know what I'm doing here. Let's put that there. Then we get this interface, and this interface is the key piece to Scaffold ETH, being able to have your smart contract here and your front end here, and be able to do things like, let's grab this person's address and let's make an address public owner and set it equal to that and hit save and then yarn deploy. And you get in this iteration loop where you're testing your assumptions, you're building on your smart contract, you're learning Solidity, and kind of this front end is kind of auto adapting to your changes as you write your contract and figure out kind of how that's going to work and look. So one fun thing I like to do on a mentorship session is just set it up so maybe like the owner can edit this first, or so the owner can set the purpose first, right? So we're going to make sure that the message.sender has to equal the owner, right? And if it's not, then we will say not the owner. Simple Solidity. We're testing it out. We're trying it out. How do we go about testing this? Well, this leads us to how wallets work in Scaffold ETH. So if I bring up a incognito window, not the Ludies. If we go to localhost, there we go, and I think it's 3000. There we go. Got a lot of apps running here. Okay, so if you bring up an incognito window, see how we have this like green account here, and then over here on my other window, there's kind of like this purple account. And there's this big annoying button that helps you grab funds from the faucet for any of these accounts kind of as they come up. But no, this is just like a burner wallet. Eventually, you can connect your MetaMask or some other wallet, and that's going to be there for you. But at first, just testing, what you want to do is just kind of use a burner wallet and kind of just click and make these transactions quickly. For example, if I want to send some funds from purple guy to green guy, I can kind of just copy this address, and then over here in the wallet, I can paste it in, and I can see visually that we have the correct address, and I can send $10. And notice how it's in USD, right? Like Scaffold ETH is doing a lot of stuff here with these components, so it makes adapt just feel and work better, right? We can click back and forth between ETH, but for the user, they're like, yes, I just want to send the $10, and I just want it to go, right? So you notice no MetaMask prompt. We have notifications locally, and that'll fill in with Block Native eventually when you go to a public network. But you can see that I can send money between those two wallets. So now these two wallets are interfacing with our smart contract. So if from this dude right here, who's actually the owner, we can see if I say hello world and I send that in, we get hello world to change. And if we do a read there, we see it. And this should fail, right? I think if we did everything right, yep, not the owner. Awesome. Okay, so it yells at us that it's not the owner. We kind of tested that line and made sure it works, but we also kind of learned how wallets work along the way, right? So let's see. The thing that I like to explain about Ethereum is that it's like this massive multiplayer game, and that this is kind of centralized. What's more fun is if we think about our smart contract as like this vending machine, right, that we want to access. And so I always do this payable example next, where instead of requiring that it's the owner, let's trigger off of the value. Let's make this thing from an attestation smart contract into more of like a vending machine smart contract. And we make it payable, and we set the message and we double check the message value is greater than or equal to like 0.001 ether, right? Something like that, and we'll say not enough. And on the other side, we deploy that, and we should see our smart contract load in. And now even the bad guy, if the bad guy wants to participate in our smart contract, can play along, right? This should work now. but it should cost me some money. And let's send in just this. And here's another developer learning point here where you have to take this times 10 to the 18 right in my UI. I force the developer to go through that clunky process so they realize we're switching into way here as we're sending it to the smart contract. And once you do that, there we go. So it did work. And something interesting has happened here though, right? This contract is now has some value, right? And what we would do is probably move on to build some kind of withdraw function or something that lets the developer pull those funds out of the contract. But whoops, I closed it up. Let's dive into that's kind of like the TLDR of getting started with scaffold ETH, right? You can pull it down from the repo, you get in, you can start tinkering with your smart contract, and your front end is going to auto reload. Let's dive in and just like look a little bit more at scaffold ETH, kind of just look at how it's set up. So you'll have these major packages. It's hard for me to show here, but it's really small. But the packages that it comes with are Hardhat and React. Those are the two like major packages. And your React.jsx is kind of like where you start to build your app. It's kind of what's displaying all this stuff. And it kind of sets up all your wallet stuff. It sets up all your providers. And then there's a bunch of handy hooks here, like use balance, right? You put in your provider and your address, and then you just have the balance of that address on that network kind of stored up in your state. And kind of digging in a little bit more to how we're working on scaffold ETH, we're kind of working on like a kind of global context, like a single context for all the Web3 stuff. So it's not as messy as this. So we are cleaning this up. and working more and more on the repo. And to dive in that in a little bit more, I'd like to talk about ETH hooks for a second. So as we build out scaffold ETH, we realized that there was all these hooks that we were using that were really, really useful. And we wanted them to be their own library, basically, right? Like having them in Scaffold ETH is really handy because we can edit them live, but it's much better if we carve those out and kind of give them back to the ecosystem as a library that anybody can use in any project. And so that's ETH hooks. So we took the hooks out of Scaffold ETH, wrote them in TypeScript, cleaned them up, put them up in their own npm package. And so now Scaffold ETH just brings that in, but you can use it as a dependency in your app too. And there's tons of handy hooks that you'll find when you get in and try to build a dApp. A Web3 app is going to just need a lot of this information, right? So just know that ETH hooks is there and it kind of is carved out of Scaffold ETH. And we're trying to do that more and more. There's components here we'd like to carve out. And then like ETH services, there's all these like if you want to use ethers to pop, like create 100 wallets and drop $5 to each one, like that's a little service, right? Or even just like an SSL proxy in front of your dApp. So we'd like to have a services repo soon too. But diving in a little bit more to this front end, things like network display, right? If I'm on the wrong network, I'd like for it to prompt me and let me have a little button, right? Your dApp needs all those things out of the box. So that's why Scaffold ETH has that built in. So when you go to put your product out there, people get a warning about being on the wrong network, and they see their blocky previews, and there's an address input with a QR code scanner. So tons of handy hooks and components and services that we found that we needed as we built out Scaffold ETH that you as the wonderful developer at home can use to build your next decentralized app. So let's see, grab funds from the faucet. So we have this nice faucet down here that kind of represents the hard hat accounts that are loaded up with cash, and they can send some money out. You can even open up the wallet of that and send like a whole bunch, right? So we got our wallets there. Let me look, I want to show off this right here. So this component is the contract component. This is what's rendering this contract here. So you kind of have this solidity here. You have your contract here, then you're deploying it there. There's some hard hat config that you'll get into and you'll learn hard hat. And then over in the front end, it's kind of injecting it into this contract component. And it's doing that live every time you deploy your contract. So it lets you really tinker with things right out of the gate. But then eventually you'll want to build an example UI, right? You'll want to set it up so maybe you, let's see, can I do that? You can hit a button and it will update that. Let's go back. So I just paid for that one, right? So I just clicked a button that went to the contract and called that function on the contract. And you can see that here in views. If we go look at that, I just do a ton of examples trying to show you all the different ways you could possibly do this. So here's that button right there that we just clicked, and basically it calls, it wraps it into transactions. We get those notifications, and you can also send raw things to that transaction, but think of it more like a notifier. And then we reach out to our your contract and we set the purpose. And you'll notice we throw this override in there where we send value along, and that's using ethers. Rick Moo will talk more later, but we use that here in Scaffold ETH, so that that knowledge will be transferable there. Okay, so let's see. So you've got your contract. You've got your app, you're able to tinker for a while. Then eventually you go ahead and you build out some UI, and then you've got, let's say, your app here, and it's kind of like ready to go, right? What's the next step to push this thing to production or to a live site? So what we'll do is we'll need to deploy this contract to a live network, right? And to do that, we can't use our hard hat. So I'm going to use a yarn, or we can't use there's like accounts that are loaded up with value on our hard hat chain. We can't like have a free account that's loaded up with value on a public network, right? So I'm going to yarn generate. Oh, I should make that bigger. I'm going to yarn generate, and that's going to create a local mnemonic here within my Scaffold ETH directory. And then if I do yarn account, I can see that account and see if it has any funds anywhere. And I'm just going to go ahead and fund that on some testnet. Looks like we're already on Rinkeby. Let's go with it. So let's send this dude, 0.1 Rinkeby real quick. Hope this works. Let's go. All right. So now our deployer within 15 seconds should have some funds, and we should be set to do something like yarn deploy -- network Rinkeby. And you can also get in and edit this hard hat file right here where your network is pointed. But we're going to deploy with -- network Rinkeby, and let's see if this goes. Please work first try. This is using hard hat deploy from Wigglewog. I think I'm saying his name right. It's a deploy plugin for hard hat. So really cool ecosystem around hard hat there, and a lot of cool plugins there, and you'll have access to those as you build out with Scaffold ETH too. All right, let's get this contract deployed. Okay, so once we've got our contract deployed, we need to start talking about our front end. We've got our contract out there, and technically our app is live, and people can talk to our app by just talking to the smart contract, but we'd like to build a front end around that, right? And so over in your app.jsx, at the top, there is this little network selector, right? And what do we want to do? We want to switch our network over to Rinkeby. And if I hit save there, our app should hot reload, and now it's pointed at Rinkeby, except for my contract's not getting deployed. maybe I could call an audible and go to a little bit different contract. Oh, there we go. There it goes. There it is. Okay, so now we're out on Rinkeby. And now's the time, like maybe we don't want to use burner wallets, maybe you want to connect in our MetaMask, and I can set the purpose to hello world, and I can pay 0.001 Rinkeby. And of course, you wouldn't have your end user have to hit that little button. That's for developers. You'll build a better UI as you build it out. Ooh, whoops. Oh man, should have cached those. All right, here we go. 0.001. Can I do it on Rinkeby? You'll notice we get the MetaMask prompt, and I can confirm that. We'll get a nice block native notify dialog down here in the bottom right. It'll track our public blockchain transaction, right? That could have been a deployment to mainnet if we wanted to. So it looks like it's all working. I'm going to do a yarn build. And that's going to build up my local React app, and it's going to have this whole thing as a static app, and I'll be able to push that out to Surge and use that app, give that app out to other folks. Now, there's a few things that you'll want to do before you go to production. There's some constants like Infura IDs that you'll probably want to update. You probably don't have those pointing to the stock one that will fall over really quickly in production, but that's 0 to 1 with scaffold. That's how you bring it up. That's how you tinker with Solidity. That's how you start learning. And that's, once you have something, it's just a couple more commands and you've got that as like a production app on a production network. So let me just dive into like what you do with that tool. Basically, that tool starts you off. You have a license to learn at that point. So in the last 5 minutes here, I just want to cover like where to go once you have the license to learn. And so the first place, like, of course, you'll look at your contract, you'll look at your front end, you'll work on your deploy script, but then check out the documentation. There's really good documentation for Scaffold ETH.
Also, proud member.
ETH Online video right at the top. Perfect, right? Happy Bowtie Friday, by the way. So in here, you've got all the Scaffold ETH stack. It kind of explains a lot of what I'm explaining already, but does it in text form. And then it kind of like gets you started with what's next, right? So once you've got the app and everything figured out, you kind of want to go on this tour of duty is what we're calling it, where there's challenges and some other stuff. And let me just dive in. Let's see. Okay, well, let's back up for a second. Make sure I cover the README sequentially. Learning Solidity, a great way to learn Solidity is just to have. There's a lot of great apps out there too, but just have Solidity by example up and just like go through these topics and kind of learn. And what I mean by that is like, okay, let's learn how a mapping works. Let's grab a mapping out of this mapping smart contract example and let's paste it into our contract and let's yarn deploy it and let's see what it looks like. And then let's poke at it over here when we have that up. So diving into Solidity, that will get you up the Dunning-Kruger. You feel like you can do anything, but then it's time to go on a tour of duty and learn kind of everything there is to learn about how what works on Ethereum and what doesn't work, and all the weird gotchas, right? And so that kind of is here. And I have this thing that I shill called the Ethereum Dev Speedrun. So if you are a Web2 developer or you know Web2 devs and they're thinking about getting into Ethereum, just tell them to go speedrun Ethereum. And hopefully when they type in speedrun Ethereum or whatever I typed in there, they will get this Medium article that talks about what we just talked about, getting Scaffold ETH up and running, getting the syntax down, but then it jumps you into all these cool example branches. So something that has come out of having this template for building dApps is a ton of dApps and a ton of branches. So there's 250 different branches here, ranging from NFTs to different starter kits and different tutorials. There's a ZK thing there. We're seeing like these lists. This composable NFT is awesome. I wish I had more time to talk about it, but getting into SVGs and NFTs that go in NFTs and render their like parents that render the children. It's really cool how it all like hierarchically renders an NFT and all on chain in Solidity. But that's a whole different, that's the side quest. As you get scaffold ETH down, you can go to any of these branches and all the smart contracts, all the front end, everything's going to be kind of the same language. Everything's going to be kind of in the same place. So once you know one good branch of scaffold ETH, you kind of know where everything is on all of them, and you know how the wallets work, and you know how to interface with a smart contract, and you know kind of like what that context looks like. Okay, so from these branches though, the speed run, once you have the syntax, once you're ready to get in, I recommend doing the simple NFT example. And the simple NFT example, I think I have right here, will take you through the same setup we just went through, but then you'll edit this mint script, and you'll, let's see, is this, what do I have? A couple minutes, let's just go look at this. Localhost 3001, you'll do the same thing where you probably want to create, let's see, a yarn deploy. Well, I have a yarn chain and a yarn deploy. Let's see if I can get it to work. Everything's in the same place, right? Guess what? Here's your smart contract right in that folder. Instead of your contract, it's called your collectible. And it's this super simple NFT example straight from OpenSea. And you can get in here and deploy that. And once you deploy it, you have a mint script, and it says, grab your front end ID and paste it in here. And when you run yarn mint, hopefully those NFTs show up here. There we go. Let's see if we can get an NFT to show up. All right. And then I'm going to grab, I'm going to grab this address. There they are. And I'm going to paste it in here. And I'm going to grab this dude's address, and I'm going to send him this buffalo. Let's make sure that, oh, I don't have any gas. Got to go to the faucet first. There we go. Now send him this buffalo. Oh, I still don't have any gas. What did I do wrong there? Oh, I sent that guy gas. That's funny. Now send him the buffalo. No, don't use my camera. Send him the buffalo. Isn't that nice that you have a QR code scanner though, right on all your address inputs? All right, cool. So the simple NFT example is your first step to kind of get context and move on to how like all these different branches work. Then start taking on some challenges. Take on challenge one. You're going to be building a staking app where you have to get a bunch of jerks to coordinate. And if anything breaks down there, then they can all withdraw. You don't want jerks to be able to grief each other. But if they all do coordinate, then money moves on to another contract, and your staking round kind of state machine moves on. Then challenge two is about a token vendor and building a contract. You'll learn contract to contract. You'll learn like contracts talking to contracts. You'll learn ERC20. You'll learn the approve pattern if you sell your tokens back. And then the third challenge is a little bit more open-ended. Build a DEX. And it's actually pretty easy using this article, but you build a very like MVP decentralized exchange and learn about reserves. And then kind of move on to take the buyer mints and start branching out, right? Take some of these branches and take them to the next step, or learn the thing that you want to learn next. And there's a whole kind of like funding mechanism with Build Guild around funding developers that are building these tutorials. So there's kind of funding available for folks that are kind of building on top of this. Let's see if we can get right back to our app real quick and see if I do a yarn surge here. I think our app is built and ready to go. And what domain? This will be, it's like a rink purpose. So I'm just going to say our purpose. PURPOSE. Let's see if I can upload this dApp, go from kind of 0 to 1 and have the dApp fully deployed. It will be at our purpose. Surge.sh. No one like front run me and get something on screen or anything. I think I'm open for questions now. We've got the app deployed. Reach out to me. I'm Austin Griffith on Twitter and Telegram. Hey, this is our purpose and I'm paying. Oh, I don't have a Rinkeby. I need to connect. Here we go. Connect my app in and say, hey, and actually pay some Rinkeby. Let's see if this works. Yes, there we go. So I went from 0 to 1. I took an app idea, brought up scaffold ETH, built the contract out, deployed the contract. Then I deployed an app that talks to that contract out to a public network where anybody could go to that URL right now, and it'll probably fall over pretty quickly, but you can use that to interface with the smart contract. And there we go. It's hey. And so yeah, again, check out the Ethereum Dev speed run. It'll take you through scaffold ETH at first, but then it will move you. Oh, I've been missing the chat. I was supposed to be watching the chat. Sorry, Kartik. Oh, it looks like we're good actually. You'll follow through a bunch of these branches, a lot of these gotchas, random numbers on chain, and how DeFi and swapping and lending work, and how signed messages work. There's lots of little gotchas that you'll learn. Build a multi-sig wallet and learn how that works. Good luck, everybody. Happy Bowtie Friday. Kartik, thanks for having me. Any closing questions or anything I need to do on this side?
I think there you go. A lot of amazing comments from the chat. I think the easiest thing would be maybe you can just log in on eThread.tv and answer some of those quick questions. Mostly it's people requesting you should have your own live stream 24/7. Call Austin. You can just always showcase scaffold ETH. One question I'll ask you is what's kind of getting you excited about things that you want to add to scaffold ETH in the future? What are some of the things that matter?
What's so cool about it is it's all these it's random things all the time. Like right now, the thing that I'm most excited about is this SVG NFT library in scaffold ETH. So there's DeFi and there's governance and there's coordination tools. There's all these different branches, but really the one that I'm most excited about is like what I made loogies with, which was just like a little SVG NFT. But it's like you get into the smart contract and you see like this is the JSON, like it's crafting the JSON in the Solidity, and then it's crafting the SVG in the Solidity. And we're doing something where you can send the NFT to another NFT, and then when it renders itself, it calls the render function of all the other ones. So then you see all the little NFTs inside of there like moving around. Super fun stuff that's like. I don't know why that gets me so excited, but I am super excited for SVG NFTs.
Awesome. Well, thank you for actually standardizing that then in that case.
Cool. Well, someone else did it. I just made it easier to fork. That's what I'm here for. Thank you, Kartik.
Thanks, Austin. We are ready to move on to our
All right, looks like we're live. I'm going to go ahead and drop a link into yes, we have Austin here, always with the most energy of anyone.
Gotta bring it. That's right. It's cold in here too. I'm in a cold room, so I feel like I got extra energy. Got the coffee going, cold room going, ready to do some building.
Awesome, yeah. I'm gonna drop this link into the Developer DAO Discord server, and then we'll get going.
Okay, good to go. Still waiting for folks to pour in.
Yeah, I mean, usually in the first like 5 minutes we start having our peak. So I think people are kind of still coming in right now, and there's so many channels in these Discords. Finding the one that I want to drop it in. I'm like, is it in general? Should it be in another one? I think we'll just go in general. Okay, cool. So yeah, welcome, and we are live now, and we are doing another stream about Web3. This time we are kind of going to be doing a little bit different format than with my Shadowy Supercoders live stream, and instead we're going to be we've been setting all this up through the Developer DAO Discord server and the Developer DAO community. And we're joined by Austin. And Austin is the person that I first met when I started getting up and running with learning this myself. So I kind of sent out a tweet when I started learning Web3. And I was like, who should I connect with? And this was like probably in February or March or something like that. And like everyone was responding with like Austin. So I reached out to him. He helped me a lot. So I'm really happy to have him here. And he's definitely the person to talk to learn anything about Solidity, Ethereum. And he has a long track record of teaching and public goods and stuff. So welcome to the live stream.
Thank you for having me, Nader, man. Like you and Patrick, I feel like I put a tweet out about this. You guys are like the new guard, and you guys are doing like way better than I could have done. It's like the amount of folks that you're bringing in, the amount of content that you're putting out, the Web 2 kind of demographic that you're engaging. It's so exciting to have other folks in the battlegrounds alongside us, like swinging axes. So
yeah,
thank you, Nader, man.
There's definitely a lot of new communities that are getting involved. There's a lot of hype around this stuff anyway. The last 6 months or so, that helps. I mean, I think like people like you are building bridges, and then people like me like walk across those bridges, and then if we also are that nature, we build our own bridges, and then over time you just have a lot of people out there helping. And the DAO itself is creating so much educational material. If you follow our Twitter feed, we just can't keep up with all of the great stuff that people are doing for teaching. And like we could do a whole episode about the reason why you might do that type of stuff, but really it comes down to you're learning, you're helping other people, you're actually helping yourself. There's so many positive things about learning in public and helping other people. And the current, the way that the internet works and the way that people are able to make connections and the network effects and how SEO works and all this stuff put together, just a positive thing I think for people to do if they can, because I know a lot of people may not have the time and stuff like that. Yeah, abundance mentality. We have so many comments. I haven't even been keeping up with the comments. Holy crap.
GMs. GM folks, GM.
Yeah, I'll probably just start popping these up as we go. So, but anyway, let's get into the topic today, which is Ethereum speedrun. Now, a lot of people, when they're asking you where they should start with Ethereum, you've been pointing them to this, and I've also been pointing them to this, and I see other people even pointing them to this Ethereum speedrun. So can you kind of like talk about what that is, and then we're going to actually go through maybe some coding or something like that.
So yes, I mean, a while back now, probably maybe even a year, I was just like, I sent out a tweet and I was just like, DMs open, come hang out, like let's get on a Zoom call and let me talk you through Web3. And I got whaled with DMs and then kind of like worked through so many different mentorship sessions where it was one after the other for weeks at a time, lots of folks coming through, but it was one-on-one and it didn't scale. But it helped me figure out like what resonates, what doesn't resonate, what kind of a challenge should I put you through so you learn. I know the topics that I want you to learn and I can just throw them at you, but it's easier if I put them in these challenges where it works you through the different concepts as you go. And so I had to do it sort of synchronously at first, right? One at a time in a Zoom call. Then kind of as a forcing function, like how do I put this thing and make this more scalable? Let's try to do 40 at one time. And that was like the Ethernet DAO folks asked me for like, okay, could you mentor a developer or two? And I was just like, let's try 40 at once. And I wrote this content, tried to put it together quickly. And that's where the Ethereum dev speedrun came from. And the reason why I call it speedrun is, I mean, like it's first of all, it's fun. Like whenever you see someone on YouTube speedrunning a video game, it's like seeing them at the mastering their craft, right? Seeing someone do a speedrun is always fun. So I liked using that concept for learning Ethereum. But also I would say back in January, February, when a lot of more mainstream folks started like popping into Ethereum, I saw a lot of tweets from mainstream folks, artist folks, and even like Mike Demerai from Rainbow talking about how all of his nerd friends were speedrunning Ethereum. So that then it like really resonated with me that like, oh, I gotta call this thing a speedrun. So now if you Google, like if you go to Google and type speedrun Ethereum, hopefully you get basically the speedrun. It shows up, I guess there's some ads now on speedrun Ethereum, but this speedrun shows up. And like Nader, like you said, like it's a little bit, it's very concentrated at first, but then it kind of opens up and gets a little wild and is a little bit unstructured toward the end.
Can you zoom in maybe a little bit?
Yeah. How's that? Let's see. So it starts, let's make that a little bit bigger. There we go. So it starts with just like tinkering with Solidity, and we'll get to that in a second. But then it takes you through kind of the concepts of Solidity, and just like if you're a decent coder, what you can do is just grab these concepts and paste them in and kind of like tinker with it. So it'll go quickly, like picking up the concepts. And then there are like these handcrafted challenges that take you through specific concepts. So the NFT example at first just gets you set up with the environment, but then we go through these challenges where a decentralized staking app and a token vendor, and I'll go through these and kind of cover these in a little bit more detail. But the speedrun is meant to just give you like a full curriculum of like all the weird things you'll find in Ethereum and why Ethereum is powerful and when it's not useful. As a Web 2 developer, it should be easy for you to pick this stuff up, but there's going to be things that you do like use Ethereum like a database at first, and you have to kind of like get away from that and understand that like the network is like a cron job too. Like when we talk about a cron job, I always talk about how this transition mentally from going from I can set up a cron job and it runs every night on my server to if I have something that needs a cron job to run, like compounding interest or something like that, and it needs to run every night, I can't just set up a single machine and have it hit that smart contract, because if you think about it, that smart contract exists on thousands of nodes all across the network. It is hella redundant, right? And it like lives on even if you want to destroy it, you can't, right? A good smart contract can't be destroyed. So then to have a single server over here that's checking in with it is not nearly as redundant, and you're as weak as your weakest link. And if that falls over, everything quits working. So to build a good cron job on Ethereum, you kind of have to turn it around. You have to say this thing is more like a vending machine, and I'm going to incentivize folks to check in with it. And I'm going to write a rule that says only one person can check in per day. And if everything works exactly right, and you've got your incentives and the economics of it correctly, then someone's going to check in every night, and your cron job's going to run, and it's going to be decentralized. But the difference between I can run a box and have it check in to this is a vending machine and I need to incentivize folks, that's kind of the difference between Web 2 and Web 3, or one small difference, and it helps you get your mind around it.
Yeah, that makes a lot of sense. And I think that the general idea of just building and writing this type of logic is so important when you're just kind of getting started. And just writing and testing and executing code is like the best way to learn. You have to get started somewhere, and it's hard to know where to get started when you're just kind of diving into this maybe from the outside without kind of having someone like you to kind of guide them through some of this stuff. Like, so for instance, I am a developer and I'm hearing all this hype on blockchain and stuff, and I just Google something. Often the first thing that comes up isn't kind of the best way to go, but also there's not a lot of guidance. When you're just saying like learning, Googling how to learn something, you might just find some tutorial, or you may not find too much. It gets overwhelming. So yeah, I think curation is something in general that's just a very valuable thing that's becoming more and more valuable as it becomes so much easier and frictionless for people to create content and for digital things to be created. We need better and more curation. I think this is a perfect example of that.
Awesome. So let's see. I guess we were kind of doing we were speed running the speed run, and I think I'll do another speed run of this in a little bit. But basically, there's challenges here. There's stuff like randomness on chain that you need to understand. There's stuff like how to build a decentralized exchange and what a decentralized exchange even means. There's a bunch of DeFi things, talking about signed messages, learning how that key pair works, meta transactions, and then like multi-sig wallet, understanding how a multi-sig wallet works and how you can make a signature-based multi-sig wallet. Someone in chat asked like for more advanced Solidity. I would check out the Ethernaut. It's like that challenges. I think it's here somewhere. Let me just search for Ethernaut. Yeah. So kind of beyond the hello worlds are this is a really good challenge. Just check out Ethernaut.openzeppelin. I'll just paste it into the chat so it's there. This is kind of like what I would say is level 2. Once you've got level 1 and you've done all of the Austin speedrun, level 2 would be diving into a more intricate kind of EVM low level, learning it. And this is if you want to go on the path of like becoming an auditor and really understanding the like low levels of Solidity.
Great. Oops, it looks like we maybe lost Austin, so I'll give him a chance to get back. And while that's going on, I'm going to go through some more of these comments and see if there's anything that I can answer. There's some good comments, but maybe nothing pertaining to an actual question. Here's Austin instead.
Sorry, dude.
Hey, it's all good. Welcome back.
Word.
We miss you.
This is the new boomer, man. I'm closing the wrong tabs all the time. My MetaMask is popping up. Okay. So let me share my screen again too. What I want to do is get right into the heart of scaffold ETH first, and then kind of back out of the onion and look at it a little bit more. So everything with the speedrun starts with tinkering with Solidity, and you can do this in Remix. You can dive into Remix and kind of just like paste stuff. But damn vulnerable DeFi is another good one. I noticed that in the chat. Let's start with tinkering with Solidity though. The very first thing you want to do is just get Remix or scaffold ETH up locally. It's pretty easy. You do like a yarn install and a yarn start to bring up your dev server. You'll do a yarn chain to bring up your local blockchain, and that's hard hat. And then you'll do a yarn deploy. And you can kind of just do this yarn deploy over and over in a loop. And it's going to be taking some stock smart contract, some template smart contract, and it's going to deploy it to a front end that's going to kind of auto adapt as you make changes. So let's see that. So let's see. We have this. I think I kind of have some. Let's see. Nope. Okay. So let's just grab something here. Let's say I have a UNT 256 public price, right? Let's set up a price function and let's set it to 0.1 ether, right? And if I save that and I deploy, what we'll see is that new price should show up over here on the right. And this is kind of the dev loop. This is the initial dev loop of scaffold ETH, where you're making changes to Solidity and you're seeing them show up over here. And if this is a function, right? Let's have a function called increment, right? It's going to be public PUBLIC. Make sure I get that one right. All right. And then what is it going to do? It's going to take our price equals, let's say price times 101 divided by 100, right? I can't do decimals, but I can do something like that where I have a numerator and a denominator. What this does is like brings it up maybe 2% with each time I hit this button. So anybody can call this increment function and increment the price for some reason, but we're just tinkering here. We're just playing around.
Yeah.
I can keep track of a price and then I can have a function. But what's cool here is once I add that function, now I get a button over here, right? So now I have a button where I can hit this button and I can see that price increment and I can see that work, right?
So does it matter like what function you write? Like as long as you create a function that's public, it will show up in the UI?
Right. Let's call it up for some reason. Only up.
Oh, sweet. I didn't realize you could.
Right. So yeah, this is kind of the heart. This is the starting kind of interesting part about scaffold ETH is now there's this up, right? So what it's doing is you're compiling and deploying your smart contract to hard hat over here, but it's also taking the ABI, it's taking those artifacts and it's injecting it into this front end. And this front end has this really nice contract component that dices up that ABI and gives you buttons for functions. It lets you put in arguments. It does a read right here on the price as it goes up, right? So it gives you just this really visceral, easy to tinker with kind of setup to let you kind of learn and go through your Solidity.
So question, why is there no MetaMask pop up for you to confirm a transaction? Is it basically like using,
let's get it. That's like one of the first things that I want to get into as we kind of unroll the onion here. So we've seen the onion, we've seen the center of the onion here, where you can kind of tinker with solidity and see this. So now let's start kind of pulling off some of those layers. So one of the first is wallets, right? So let's open up an incognito window and let's go to localhost 3000 where my web server is running, and you'll see that I get a new account here. See how that pink one showed up? Let me close that. Let me do that whole thing again, and let's get what it's doing is it's using a burner wallet, and these are almost never used in production, but super great for local development. And what a burner wallet is basically I've got a private key that's stored in local storage, and anytime I click one of these buttons, it's going to make a transaction behind the scenes, and it's going to sign it with that burner wallet, and it's going to ship it off. So for me as the developer, I'm just clicking buttons and poking at things and making sure it works. But what I'm not running into is a MetaMask pop-up, or MetaMask being on the wrong chain ID, or MetaMask
totally.
having the wrong nonce, right? Like you don't want to mess with that. And anybody
right.
who gets into that always runs into that, right? Like you see that in the chat in chats from 2016, 2017, 2018. Everyone's like, why is this MetaMask problem happening? Well, MetaMask isn't really great for local development. You do want to test your app, obviously, and make sure that the UX works well with MetaMask, but you don't want to do that until you get to a public testnet, right? So anytime you're just on localhost and you're tinkering around, burner wallets are really great. And so what I can do here is I can grab some funds from the faucet. It's like big annoying call to action, but what that does is give me some funds from my local local hard hat node, and then I can use this wallet, right? Like it's a normal wallet. I can open it up. I can type in AustinGriffith.eth, and I can send myself $1 of testnet funds for some reason, right? And eventually, if I were to connect AustinGriffith.eth, right, that maybe. Putting in passwords. Here we go. Come on, MetaMask. Another reason why you shouldn't use MetaMask locally. I'm waiting 10 minutes for it to finish loading here.
Is it on the right network? Yeah, I guess so.
Yeah. Okay, so this is another great thing about Scaffold ETH is out of the box, you're setting what network you want it to be. Right now we have it set on localhost, but we make one change and we change it to mainnet. All of this stuff transitions. So when you click on an address, it takes you to the right block explorer and all that stuff. But it also gives you this nice network warning. So I can
quickly
switch to
just kind of
localhost.
talk about how that happens. So for instance, if you interact with a Web3 application, a lot of times it will say switch to this network. You click a button and it does that for you. Ethers.js or Web3.js or have APIs that allow you to kind of write that kind of code, right? Is that how you're doing it?
Yeah, the switching. So basically, Scaffold ETH has this app.jsx, and there's a target network there. And if I set that target network to Rinkeby and hit save, now my whole app is going to be switched to Rinkeby, right? And look at that, there's actually a smart contract out on Rinkeby that has this exact same thing. It's like in my artifact still. That's funny that it switched to that. So then if I were to connect my MetaMask, it's going to say, hey, you have it on localhost, you need to switch to Rinkeby, right? And that switch network comes up. So that's just an API that's involved with MetaMask. You trigger the network switch there, and it handles that. So this is something that Scaffold ETH is going to handle for you out of the box, right? You've got your burner wallets, you've got this nice network selector, all of your addresses. Now if I click this, it's going to take me to the Rinkeby block explorer because I'm on Rinkeby, right? If I switch this over to Kovan and hit save or mainnet or whatever, it's going to say, oh, hey, you need to be on Kovan. And when I switch over to Kovan, and all the addresses now when I click this are going to take me to the Kovan block explorer, right?
Okay, I have another question.
Yep.
I don't even know the answer to this. I mean, I kind of have a general idea, but maybe I'm not sure. So what are the differences between the three test networks? Like I feel like I see Rinkeby used more often than Ropsten or Kovan. Is there a reason for that, or is there any big difference?
So my answer usually comes down to composability and what other things live on that testnet. So Rinkeby has OpenSea, right? So if you're doing NFTs, you almost always want to go to Rinkeby so you can make sure they look good on the Rinkeby OpenSea. Ropsten is a proof of work network, right? So it's probably going to fall over sometimes, but you can get a feel for how those long-awaited proof of work transactions work over on
Wow, I
Ropsten,
didn't know
right?
that.
Yep.
Okay.
And then Kovan is also a proof of stake, I think, like Rinkeby, but it's faster, so the blocks are like, and I think a lot of DeFi stuff lives over on Kovan. Like if you were testing Chainlink VRF, I think you would go to Kovan for that, right? So it comes down to composability. It comes down to kind of like how you want the network to work. Sometimes just testnets are kind of very attackable networks, right? They don't have the giant network effects that mainnet has. So sometimes just a testnet is down and you have to just use a different one, right? So it depends on what else is composable, what else you want to use, and also like what you want that to look like, what you want, how long you want those transactions to take. So that's my testnet rundown.
Yeah, that was actually really helpful, and I learned a lot actually. Thanks.
Oh, hell yeah. Okay, so we've got wallets figured out. Basically, you're gonna have a burner wallet that's gonna be generated for you, and it's gonna let you easily check in and call these functions, and you're gonna be able to see things kind of update live, and you're gonna be able to poke it at your smart contract. So what do we have for our smart contract here so far? We kind of have this purpose, and then we have some function that lets us set the purpose, and then we have some price that we're incrementing, right? So if you're first getting into Ethereum, the first thing you want to do is kind of just tinker here, and then write your first rule. Do something like require that the message.sender is some owner, right? So let's make this dude the owner, right? So we'll do address public owner equals this dude. We'll kind of paste that address right in there, and then we'll say over here, let's make sure the message.sender equals the owner, and if it's not, we'll say not the owner. Okay, so we just like totally changed how the smart contract works. Instead of anyone being able to get in here and set the purpose, now only the owner can set the purpose. And we'll see over here that this new owner shows up and it matches ours. And if we say hello over here, it should let us set the purpose. And if we come in here with a bad guy and we test it out, this bad guy should get the error. Once he grabs some stuff from the faucet, he says hello, hello, it should give him not the owner, right? So we kind of test that line of code, and we're able to kind of even audit it just by playing around with the UI. The fact that it's like so easy for us to poke at this lets us like test and try things out. So let's actually get rid of let's do this. Let's make it so only the owner can make the price go up, but we don't really want the owner to be the only one that can call set purpose. We kind of like this cool set purpose, and we want to think of this we want to think of Ethereum like this massive multiplayer RPG, right? So what we want to do is set this up so this is a payable function, and we'll do something like message.value, right? It needs to be greater than or equal to the price, and then we'll say not enough. So now we, again, a couple lines, this is the superpower of Ethereum, a couple small changes to Solidity completely change how this whole mechanism works. Now we have this owner that can increase the price with a button click, and we have this purpose that lets you set the purpose, but then makes you pay like a vending machine, right? And so let's just come in now as kind of that adversarial second person over here, and now they should be able to set the purpose, but look, our front end has auto-adapted, right? Now there's this new transaction value. If I what was our price? Oh, our price is 0.01, we can see right there. If I go 0.1, and this is, watch this now, this is something I make the developer do, it's kind of annoying, but it's on purpose. You have to take it times 10 to the 18 right here in the UI. So this helps the developer understand, first of all, this is the developer's UI. You want to carve this out and build your own UI eventually, and I kind of walk you through, here's how you display things, here's how buttons work, here's how you make a button that calls something on a contract. But when you're over here and you're tinkering with things, I'm force you to do something like take it times 10 to the 18, so you understand Wave versus ETH. And if I go ahead and send that, oh, we don't have any money. I need more money. Here we go. We can go to the faucet, we can send ourselves a bunch. Here we go.
Nice.
And now if I hit send, there we go. So we're gonna pay what we ended up paying, $400, but we set the purpose now, right? And as the admin, we can come in here and say, okay, now let's increase the price a little bit. And this is very centralized. You don't really want a single person to be able to get in here and just click and increment the price, right? Like really what we should do is probably have this down here and have the price go up every time someone purchases it. Let's do it. No owner, all of that. Go ahead, sorry.
Yeah, no, I was gonna get to a couple of questions and just touch on a couple of things real quick while we're going through all this stuff. One of them is actually really pertinent to like what we're supposed to be doing here anyway. Something that I kind of led on in the announcement is that we're giving away a free developer DAO NFT. So someone said, how do you join developer DAO without spending gas money during minting? Well, the answer is you respond to the tweet that went out from my Twitter account, and I'll go ahead and paste a link to that here. And just respond saying that you want to be eligible for the NFT, and we're gonna give it away at the end of this. So I'll kind of go on there and just find a random person and just give it to them, I guess. Or maybe I'll just like, I don't know, we'll have to come up with some way that we can do it that makes it not, that makes it very variable or whatever. But either way, the idea is that like the question was, how do you get into developer DAO without spending gas money to print an NFT? So when we launched the DAO, we made it that it's a token gated community, and if you want to join the community, you need to have one of these NFTs. To get the NFT, you can mint it for free. Essentially, meaning that the NFT costs no money; you just have to pay for the transaction itself with gas. And at the time, it wasn't that much, but now with the last couple of weeks, especially, it seems like the network has become more congested and it costs a little bit more. So we've been giving out a lot of these. I've given out at least 40 or 50 of them at this point. I'm going to continue to give more of them out up until we're out of them because we're kind of getting close to being out of them anyway. But yeah, so if someone wants to get in for free, just look out for the next big giveaway of like 10 tokens, or just respond to that tweet saying that you want that. One other question that I think is something that I want to talk about, and it has to do with Solana. So one of the things I've been tinkering with is Solana lately, but I think just walking through Solidity here is a good chance for me to kind of talk about some of the differences that I've seen real quick. And one of the biggest things that I really am kind of starting to appreciate about Solidity is how easy it is to do things like authorization and deal with authorization scenarios, and doing things like having the message.sender available directly and easily. And it makes so much sense when you kind of start playing around with it. The required statements in Solidity are just really easy to work with. I found Solana really, really tough to kind of get to the point where I felt confident enough to write anything that wasn't just really basic, but it's something I would like to focus more on. So I would say that if you're watching this and you're interested in learning smart contract development, I would very highly encourage you to start with Solidity, because you can actually build across dozens of EVM networks, not just Ethereum, and you can kind of at least feel productive. Whereas I feel like Solana is a little bit higher barrier to entry right now. That doesn't mean you shouldn't learn it. Definitely, you don't. I'm not discouraging anyone from doing that. If you do look at Solana, though, check out Anchor. Anchor is kind of like a nice developer framework for working with Solana. So I just want to kind of cover those two, and we're going to jump right back in now with Austin. And there's tons of other questions. We'll try to get to some of those later as well.
Woo. Yeah, I will say that I'm an EVM maximalist almost always just because of the tooling. This tooling has been, it hasn't been so good for a long time, right? Like early EVM tooling was really hard to use too. Like the tooling has finally like come around the corner, and it's like actually pretty smooth to use, and it's pretty easy to get in and build these Solidity apps. Okay, so we've looked at kind of the heart of scaffold ETH, allowing you to kind of tinker with a smart contract, write these rules, and then have it show up over here and be able to interact with the smart contract. So to learn Solidity, if you're a Web2 developer, it should be very easy. You're kind of going through the speed run. I talk about going to Solidity by example and then kind of picking these up. So like primitives and data types we've already run through, basically like UNC. You've got numbers, you've got bools, and then you have like addresses, and you kind of have that address, like just raw in there, no quotes around it. But you'll pick it up as a developer, you'll pick up this syntax very quickly. So after primitives and data types is mappings, and you'll go to here, you'll look at here's a mapping, right? And what we do, you can just copy and paste that mapping over here. And now we have my map, right? Let's call it balances though, right? Because this is what a mapping is usually for. And let's deploy it. And now we'll see our app auto change here. And this is what it's all about. It's just like, okay, how does mapping work? Let's throw this mapping in here. Okay, so it takes an address and it gives me back a number. That number is 0 right now because it's not tracking anything. But let's do something like, let's do the balances of this dude equals 100 ether, right? So now he's got a whole, and by the way, if this is a token, maybe we don't want to say ether, maybe that's hard to understand. We can do 10 to the power of 18, same thing.
Ooh, this is really good right here. Because like when I'm working in Solidity, and when I started writing Polygon, I was using ether, and I didn't realize that it was just kind of like a placeholder for a number, right? That's kind of essentially what that is, right?
Yep, exactly. And this number, like we didn't really dive into this ETH versus Wei. Kind of when I was over here and I did 0.001, and then I converted it over to Wei. So this is ether, right? And this is in Wei. And you can look up like ether versus Wei, and there's going to be a nice chart here somewhere that's going to kind of show you where, there we go, something like this, where like the single smallest unit in a smart contract is Wei. So if I put a 1 here, that's going to be 1 Wei. So by putting 100 here and then multiplying it by 10 to the 18, that actually takes it to ETH. And the reason why all of that happens, as far as I know, is basically like the EVM needs to be simple. This little node right here that I'm running needs to be as simple as possible. And if we build the EVM so it doesn't have to F around a floating point map, it makes it a lot easier for other people to run. So it makes it more decentralized. So this like number conversion you have to do as a developer is just because the EVM is more simplified and it doesn't want to do floating point math. And also notice down here how we did this. Why didn't we just take this times 0.02, right? Because you can't do it has to be a whole number. So we do this, and you can even make sure you have your order of operations right, where we do the price times 102 and then divided by 100, right? And that gets you that price up 2% effect that you want. Okay, so
cool.
So you're going through the speed run. You're pasting these things in here. We're learning mapping right now. I pasted in a mapping. It's a balance. I'm just going to set the balance to 100 for this dude. I'm going to deploy it, and then if we go back and look at our app, we should get a new smart contract to show up here. Yep, there it is. And then if I check my balance, there it is. It's 100, right? And then maybe you have some transfer function, right? And this is basically how an ERC20 works, right? So we have an address to, and then a UA256 amount, and it's public, right? Anybody can call it. And basically what happens in a transfer, you do what, like balances of message.sender minus equals the amount, and balances of the to address plus equals the amount, right? So this is where you're getting into. You're just kind of tinkering. You're learning with Solidity. You're learning how this kind of stuff works. You're testing your assumptions. You're trying this out. Now let's see what happens. So now we should get a new transfer function over here, right? And if I check my balance, it's at 100. And then if we bring up some other jabroni again and we take him to localhost and we grab this guy's address, little orange guy here, and we say transfer. Notice how we get this nice blocky preview. It lets us know we have the exact one. And then let's transfer 10. And this would be 10 Wei, but I have 10 ETH, right? Let's do 10 times 10 to the 18 and hit send. Now if I check my balance, it's at 90. What if we check this dude's balance over here? It's at 10, right? So we were able to kind of like just build a token just by bringing in this mapping balance and creating a transfer function.
Look how simple and smooth sending payments in Solidity is compared to anything that you've ever done before in any other area of software programming. Like if you ever worked with the PayPal API or even the Stripe API or any API where you're dealing with money, I mean, it can literally take you days, weeks, or even longer to kind of set up a secure and something production ready for actually making that payment and understanding that's going to work. But I think one of the biggest things that blew me away when I was learning Solidity was being able to send a payment in like a couple of lines of code and being able to just test that by switching onto the Rinky network. And that was it. There just wasn't anything else, and it was just mind blowing, mainly because of the pain that I felt throughout my entire career anytime I dealt with payment APIs. And I think when you kind of see that, having gone through that, it's a lot different than maybe even if you hadn't had to deal with that in the past.
Yeah. Okay, so I'm going to pay this. So we're back to whoops, I don't have enough money. Dang. I made this too expensive. Okay, so let's say you've got it now. You've got scaffold ETH down. You're able to look through Solidity by example. You go through each one of these topics. You learn about structs. You learn about modifiers. You learn about events. You learn about inheritance, payable functions, the fallback function. Now you have a license to learn. You have a local environment. You understand most of the syntax. You can write the simple Solidity. Solidity is actually very simple. Anybody can write Solidity. They can write JavaScript. Now writing a complex, sophisticated smart contract system that all works together on mainnet, that's incredibly complicated. But just getting started and getting Solidity and tinkering is pretty easy, and you should be able to get in and get that going with scaffold ETH pretty easily. So now it's time to kind of start learning. So the first branch I take you to is a simple NFT branch. And what you'll do is everything. The cool thing is there's hundreds of branches of scaffold ETH. Everything is in the exact same place. It uses the exact same tools. The smart contract is in the same place, and it's going to work you through. I can probably make this a little bit bigger. Yep. You're going to do the same thing. You're going to do a yarn install, a yarn start. You're going to do a yarn chain to fire up your hard hat, and then you'll be deploying to whatever network, whether it's localhost at first or then some testnet. It's going to walk you through minting, right? Taking some artwork and putting it into IPFS, and taking that hash and putting it into the NFT. And the NFT, by the way, let's go look at the contract. We know right where it is, right? Let's go to. It's going to be packages, hard hat, contracts. Instead of your contract, it's your collectible. But everything's right here. Look how simple this contract is. So simple, thanks to inheritance, right? We're inheriting from Open Zeppelin the ERC 721 contract and some counters. And basically what we do is we say only the owner can get in here and call mint item, and it increments some token IDs, and it mints your token, and it sets your token URI to whatever the token URI is, and that's the stuff that's in IPFS. You'll run through this. You'll mint your
owner means that the person that deployed this contract.
In this case, In this case, only the owner can mint them, because what the owner is doing is just getting in here and minting themselves like 12 of these collectibles and sending them around. And you'll do the same thing where you bring up an incognito window and you send it to the incognito window and you see the NFT disappear from one side and show up on the other side. So and this will take you all the way through deploying to a live network. So this will have you deploy to Rinkeby, and that's kind of a key piece because you'll need to generate a deployer account and you'll need to fund the deployer account, and then you'll put it out on that public network, and you'll do that thing where you switch to target network like I was doing earlier, and your app will kind of auto adapt to that. You'll go to OpenSea with it. You'll verify your contracts, just like a ton of stuff that you do in Web3. This first NFT example is just basically following directions. I walk you through going from 0 to 1, putting an app out on a public network, putting the contract out there, minting some NFTs, sending them around. This is just like the starting point, right? This just gets you so you understand a little bit about just the context of how to use the tool. Then I kind of like allude to the fact that all of these branches are just branches that started from scaffold ETH, and then they've kind of like, they forked over here and became an NFT, and then it forks again and it becomes the buyer mints. So this is an extension of the simple NFT. The buyer pays, what is it called? Buyer mints NFT branch. It's almost exactly the same, but this time there's a gallery, and the buyer clicks to buy the NFT and pays gas. So it's just a little bit different, but it's a tweak on how the simple NFT works, and it shows you like small tweaks to the code create entirely new like mechanisms. So once you're ready to really test your knowledge, this is when we get into these challenges. This is kind of the heart of the speedrun right here. And if we get in here and look, the first app you're going to build now at this point, I'm not going to hold your hand through Solidity. At this point, you need to understand how to write some Solidity. So you need to kind of go through that curriculum from earlier and kind of get an understanding of it. But once you have that, follow these challenges. So this takes you through building a staking app. And this is like a superpower of Ethereum. Getting a bunch of jerks that don't agree, that are adversarial, to coordinate financially to put something together is actually something that like Ethereum is really good at. Because what you do is you write the smart contract. And again, it's like a vending machine that anyone can get to, but you write the rules in that smart contract exactly how you want it to work. So no one can take each other's money. Like all they have to do is trust the code. There's some timestamp threshold that says we have to get enough money before this deadline. And then if you don't get enough money by the deadline, you need to kind of put that state machine in a withdraw state and then allow people to withdraw their money. So you don't want people to be able to get griefed. You don't want people to get their money locked up. You assume that everybody is an adversarial jerk, but you can still write the rules correctly. So those jerks can all come into this contract and they can stake some funds and they can actually coordinate to get a bunch of money together to buy some NFT or to put it into a multi-sig or something like that. So this is the staking challenge, and it'll take you through the whole thing. Again, yarn start, yarn chain, yarn deploy, everything you're familiar with scaffold ETH. I walk you through a few things to put into your contract, but a lot of your contract has to be written by you. And we'll go through, we'll get it working. You'll ship the smart contract, you'll ship the front end to a URL, and then you'll turn in your actual, you go from 0 to 1, you build a whole staking app. You'll turn in your app URL to a Telegram group, and I'll get in and I'll follow the link and I'll go stake into your app and make sure it works, right? Me or some other scaffold ETH helper, right? Like we've got lots of people building and helping with scaffold ETH. Shout out, they're probably in the chat right now. So that's challenge 1. You'll build a decentralized staking app, you get jerks to coordinate. Challenge 2 is a token vendor. So what you'll do here is you'll build, you'll deploy an ERC20. You'll deploy an ERC20, right? Just a simple ERC20 token. There's hardly anything there. You'll write a little bit of code here, and then you'll create a vendor for that. And what the vendor is again just like a vending machine. It's another smart contract. It's going to hold your ERC20 and sell it to folks. And then the cool thing is buy the tokens back. And that's the neat piece about this challenge, because it's going to teach you about the approve pattern. And the approve pattern is kind of a pain in the butt, but that's like part of this like speed run, is not only getting you exposed to the good things about Ethereum, but also the bad things, and understanding like when you're going to have a hang up. And the approve pattern is so bad. So you're learning contract to contract interaction here. And in particular, the approve pattern says if I want to sell my tokens back to this vendor, I have to go to the token contract first, and I have to approve the vendor to take them. Then in a second transaction, I have to go to the vendor contract and say I would like to sell tokens. And atomically in that same transaction, it goes and gets the tokens, brings them here, only if they're approved, and then executes some other code. And that like mental model you have to get to be able to understand how a ton of things work on Ethereum. It's like kind of how that pattern works. And this will take you through that, and it'll have you run into that.
One of the things that I was kind of blown away by when looking at scaffold ETH is that there are over 200 branches now. Is that right?
Yeah, there's so many. Let's go.
There's like 200 branches, and each branch is literally an entirely completed full stack application. I think they're all full stack, right? It's not just most of them have a front end. So like you have over 200 reference architectures for almost anything that you want to build, it seems. So if you're like, oh, I want to build out an NFT marketplace, you don't have to start from scratch. You actually can start, in my opinion, it's smart to kind of maybe start from here and
have a signature-based NFT auction. So you're building an NFT auction where people sign things off chain and it settles on chain, right? Here it is with a README. Sorry, I didn't mean to interrupt you there.
No, this is dope.
Yep. So when you're going to build something, and also like check out buildgittle.com. We have a lot of our kind of starter kits here too, right? A starter kit to let you use a Merkle tree to mint NFTs, right? Or I'm just kind of like randomly landing on these. An Aave 8. It's a starter kit for how to leverage up in using the Aave SDK, but in scaffold ETH, and you basically build your own leverage contract that kind of rolls up a position for you. But so many things to find in the branches of this, right? Maybe you're thinking about like a commit reveal pattern, or maybe you're like, no, I don't want to do commit, I want to do VRF, right? Or is there an Oracle example? Results Oracle, right? Ooh, the Notes to Safe starter kit. This is one of my favorites. So a lot of what we found with DAOs is that you don't need to write an intricate smart contract at first. You can just use a multi-sig. And so
this is a multi-sig like contract instead of using like a service.
Exactly.
You just like write your own.
So this uses the Gnosis Safe. So it deploys a Gnosis Safe for you.
Okay, so that's
the whole experience
is just a contract, right?
Yep, it's a set of smart contracts. It's like supercharged multi-sig. It can do all this delegated execution. It can do all these modules. You can add all these things to it. Like the Gnosis Safe is really finding product market fit now that we have these governance tokens and things need to be decentralized.
The first time I used Gnosis Safe, I was kind of just like thinking that this is completely maybe like a game-changing type of application that is going to have ramifications for a long time, like for how we do a lot of things. So yeah, I definitely recommend checking that stuff out. You can actually create a Gnosis Safe on their website as well, just play around with it, or build one here and deploy to Rinkeby, and you don't have to spend anything.
I would recommend that. So basically, my onboarding for developers is take on these first few challenges. Let me sponsor you to get an ENS address, right? Take on.
So what does that mean? You're going to pay for the ENS address?
I usually pay gas for developers to get their ENS address. Well, I mean, like it's so good to have an ENS address, right? And then like whenever you get into, so if I go to Nifty Inc, okay, so there might be some penises drawn on the screen here, but if I go to Nifty Inc, look at in the bottom right, I have AustinGriffith.eth. See that? Right. So that's using this. So this was using scaffold ETH, by the way. And this is one of the only apps that actually uses a burner wallet. If you go to Nifty Inc, oops, I should shut those down. If you go to Nifty Inc on a tablet, right? If you have an iPad and you just type in nifty.inc, you can get straight into I can make an NFT, and it records my movements. And if I hit playback, we see it, and it puts that into IPFS. And this is actually using a burner wallet. I can mint this on chain on a side chain. It upgrades to mainnet. But this is one of the only apps that actually uses burner wallets out of the box. Dark Forest is another one. The game Dark Forest on XDAI, they use burner wallets because they've got to be doing lots of transactions behind the scenes. Okay, let's see. What do we got? We got 10 minutes left. The speed run we've kind of talked through. So after you do challenge 1 and challenge 2, you need to build a dice game. You need to build something that does randomness on chain because you need to learn about randomness. At first, what you'll do is probably do some kind of, let me go look at the Loogies contract. It's got some interesting randomness in it. So where's the smart contract? It's in packages, hard hat contracts, right? Where all the other things are, right? Let's see. Here's how we do randomness. Here's a predictable randomness. We take catchak 256, which is a hash function of ABI encoded. And what we're doing here is really interesting. Is basically like block hash, block number -1, right? So we're saying the previous block hash is pretty random. So we're going to grab a chunk of that and make that our random number. Now this doesn't work because you could set something up that like watches for a certain block hash and mints only when you need to. So there are ways to kind of like break this randomness. And that's the point that I want you to learn. I want you to learn why a previous block hash works in some cases and doesn't work in other cases, and where those are. Learn about commit reveal and why the user experience is not so great. Sometimes you have to put in a reveal and hold the reveal, and you have to do multiple transactions. So no one likes commit reveal either. Building an understanding of DEX, right? You'll get in here and actually like learn how a decentralized exchange works. And the TLDR is it keeps reserves, and it has a pricing function that has to do with the ratio of those reserves. And you'll go through and kind of learn how that pricing function works just by building your own DEX. And the code is actually really simple. It's using like very first version of Uniswap probably, and it's ported to Solidity. So it's really easy for a Solidity developer to get in here and even like copy and paste this code, and you'll get down here to this price function. And this is the kind of the most important part. Here's that price function right here. It's basically looking at reserves and giving you, if you put in some based on the reserves, this is what you'll get out, right? And it'll take you through all of that. You'll learn about decentralized exchanges. The DeFi stuff, like you said, this starts to get a little bit unorganized. And I would you should still run through as many of these as you can. But those first few challenges, building a DEX, building a random number game, some kind of game, those four are like very critical. The rest of these are more like, okay, what's next? What do I want to explore? If you want to get into DeFi, you should learn how to short a token in a smart contract. You should learn how to leverage up in a smart contract. If you want to get into NFTs, maybe you don't need to know that stuff, but you need to learn more about IPFS. You need to learn how you could build an SVG NFT, which I think is like one of the onboarding for developer DAOs too, right? Isn't developer DAO doing like an SVG NFT as like?
Yeah, we basically forked the smart contract that was for the, what is the name of that thing that Dom created? Yeah. Yeah, so I'm a big fan of SVG, and I think we'll see more of that as the gas price becomes less of an issue in the future, not only on Ethereum layer 1, but on other layer 2s and stuff.
Word. Yeah, so let's say you wanted to get into SVG NFTs, right? Oh, cool. There's my validator. Let's go to Scaffold ETH, right? So Google Scaffold ETH or Google Speedrun Ethereum. You're going to land here. Let's go to the branches. Let's look up SVG. Ooh, composable SVG NFT. So this is a really, really cool one, and it's fun to show off in the last few minutes here. So when a Loogie is drawn, right? Basically, what we're doing here, let's get into the smart contracts. It's drawing an SVG in the smart contract. So let's look at the smart contract. Look how simple and clean this is. I mean, it looks a little complicated, but for what it's doing, this is actually very simple. So we're doing that same ABI encoding. So we're basically concatenating strings. And look at this. We're making that JSON file. So there is the manifest, the JSON manifest for what an NFT looks like. So this is what OpenSea wants to see. We're making it right here. And then if I scroll down a little bit, there's a render token function. And look at this. Here's the SVG. Here's one eye, and here's the head, and here's the second eye. So it's just drawing.
You guys have variables in there.
Yes, look at this. The chubbiness is actually a variable on chain, right? So the thickness of the loogie and the color of the loogie are things that are actually on chain. And so now you can breed these, right? We could breed two loogies where we mix the color and we mix the chubbiness, and you get a new one, right? And by the way, let me just go. I can go to OpenSea and look at these loogies just to show them.
Yeah, I think NFTs on SVG NFTs are definitely my favorite type because they're just so immutable. Like they're there, they're not going anywhere. I mean, they're on chain.
So here are the loogies, and you can see the width change, right? So here's a fat loogie. Look at this. We can go see, the color and the chubbiness on chain, right? But that's actually, this is an SVG, right? Like this is a straight up just an image that's being drawn in the contract. Okay, so here's the cool part. Once we have these loogies being rendered on chain, so let's show that again. There's the eye, there's the head, and there's the eye, and that's what makes this eye and then this head and this eye, right? So it's being drawn in the contract. So here's where composability starts to get really interesting. We start thinking about, well, what if I want to send Natter like 10 of these loogies, right? Or what if I want to have these in a jar somewhere? So the loogie jar idea comes up. And so what we did is we created another NFT, and it fits the same standard where it's rendered in the smart contract. It's an NFT itself. It's a 721. So I can send you a loogie tank. And what a loogie tank is it's drawing like a blue kind of square for the tank. And then when you do the render, again, same thing, JSON file. When you do the render, look what it's doing. It's doing this render loogies. So it's going to draw a rectangle for the tank, and then it's going to look through all the loogies that it owns, and it's going to render each one of those. So the render function in the loogie is public, and it's looping through, drawing all these different loogies. So if I go, let me see if I can find a link to this. I have a video of them like swimming around in the tank. What we did was we did a little bit of animation, and then we did a little bit. We put them in the tank deterministically. Let's see if I can pull this video up. Let's see. Oh yeah, here it goes. Yeah. See those loogies swimming around? Isn't that cool?
Yeah.
So your loogies are being rendered inside. So this is one NFT. You can own the NFT. You can fractionalize the NFT. You can send the NFT around, and inside of that NFT, it owns all these other loogies, and they're being rendered live. So you can imagine that like the loogie gets fatter, or the loogie changes color, or the loogie's breed and a new loogie shows up, and all of that is rendered on chain. One is rendering the other in its own render function, all on chain. So much fun stuff with composability you can do with these SVG NFTs.
This is so dope. Yeah, I learned so much, and I'm assuming that a lot of other people did too. We have about 2 minutes left, and I need to also do the giveaway for the token. But before we do that, are there any final things that you want to leave people with?
Speedrun Ethereum. Like the thing that I will say is just Google Speedrun Ethereum. If you're a Web 2 dev, go Speedrun Ethereum. Go take on these challenges. They won't take long. You'll get through it, but it will give you a whole mental model of like how and why Ethereum, and it will give you the tools you need to build whatever you want to build. And so Speedrun Ethereum. Check out the branches of Scaffold ETH to find kind of like your next build. Check out the Build Guild for like an incentivization layer. I kind of do like UBI for developers. So there's a lot there, but it all starts with just speedrunning Ethereum and getting Scaffold ETH installed locally. My DMs are open. I'm at Austin Griffith. I guess I'll keep AustinGriffith.com, but I'm at Austin Griffith on Twitter. And right now I'm a buffalo with a pink bow tie. Cool. Awesome. Hearts. Thanks.
All right, here's what we're going to do. This was amazing. Yeah, thank you for coming on. I'm going to share my screen now. We're going to do a live giveaway. So I'm going to see if
live giveaway.
Yeah.
Happy Bow Tie Friday.
Okay, cool. So can you all see my screen right now?
Yep.
Okay, cool. So I'm basically going to do like a snapshot of all the people that responded to this. And I have a function called getRandomInt. That's just basically I'm defining, and I can like just pass in the number of people that have basically submitted their eligibility for this token. And I'm just going to go ahead and get a random number, and we're going to do it this way because this seems like the most logical way to do it. So how many people have we had? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got 13 people. So I'm going to call getRandomInt. So I'm going to pass in 13. And it looks like the winner is number 10 right over to you, and you can join the DAO. So that's it. Congratulations. Yeah. So thanks for everyone that check this out. This was a lot of fun. We're going to be doing a lot more of these. So stay tuned.
That on the NFT show off with Sean on.
That's right.
Yeah, it's a good one. It's funny. Like I'll like see developers out and they'll do like, yo, guys, we're in the middle roll. So we definitely memed that into existence on that speed run. Okay, so here we go. This is Scaffold ETH, and to zoom right in, it starts off where you get your smart contract over here, and you have the front end over here. And as we make a change to our smart contract and we yarn deploy, that's going to go to our local network, and then those artifacts are going to get injected into our front end, and our front end should reload over here and give us that new value with some exclamation points. So this is kind of like the starting point for Scaffold ETH. This is your license to learn, and you can get in here you can start adding things and start tinkering with Solidity and just get a feel for how Solidity works and then go from there. So the thing I like to show to everyone is the Ethereum dev speedrun. If you know a Web 2 developer, or you're a Web 2 developer just getting into Ethereum, or you're a Web 3 developer even trying to find your blind spots and go through the tour of duty, check out I'm just gonna ETH dev speedrun. Just tell your developer friends to go speedrun Ethereum, right? And that speed speedrun is important because it's not just about learning the syntax, it's about learning all the interesting gotchas and what Ethereum is good at and what Ethereum is not good at. And so it really starts with just tinkering with Solidity. You get this scaffold ETH setup going, and the curriculum starts with just like, go to Solidity by example. You're a smart person, you understand how to code stuff, or you can write a for loop, you know how to do this. Just get in here to Solidity by example, look at the first hello world, get in here and start looking at primitives and data types, right? And what I mean by just copy and pasting in is you can really just grab something from over here and you can paste it in to scaffold ETH, and you can yarn deploy. Oh, whoops, I don't think I hit save. Ooh, here we go. And then you should be able to see that new, so we created an address over here on, weird, the hot reload's not working over here. There we go. And then our address shows up over here, right? And let's copy this dude's address and paste it in here and hit save. And let's go ahead and deploy that. You're seeing this dev loop that I'm doing here, where I'm making small changes over here, and we're seeing in the front end that they reload over there. Okay, so we can kind of tinker and we can test our assumptions and we can try things out. We can learn the language, we can learn the syntax. And if you've learned a programming language before, this is gonna be super simple to pick up. Solidity is actually a pretty simple language. I mean, you're not diving into assembly and everything. It can get very, very complicated, but picking it up and getting the basics should be pretty quick. So you got integers and unsigned integers and this address that we just posted in. You've got booleans, right? You can imagine. Let's put in a boolean just to see how it works. And save and deploy. So now we should have an address, and we should have bool equal true. And let's see, there we go, there's bool equal true. Okay, so I'm just kind of tinkering with the syntax and getting a feel for it and learning how this works. And that's the start of the speedrun. Now you'll go through a handful of different topics. You'll learn about mapping, structs, modifiers, events, inheritance, table functions, the fallback function. We can kind of cover some of these as we go here, but take the time, sit down, take a couple hours and really work through this stuff on your own using this scaffold ETH setup. So just to back up just a little bit, to get scaffold ETH, you can just type in, let's see, I'm sure you can just Google it, and probably the first thing is the scaffold ETH GitHub repo. There we go. And so there's scaffold ETH. To get it started, you'll clone down scaffold ETH. Let me see if I can make this a little bigger. You'll clone down scaffold ETH with a git clone, you'll yarn install, and you'll yarn chain. And be careful with yarn. Some people end up using the yarn from like Linux, like there's like a Linux command called yarn. Be careful with that yarn. Make sure you like npm install -g yarn and get it from npm, but it's just an npm drop-in replacement. We use it because we have workspaces. We have a couple different things. We have hard hat React. This kind of brings in a full stack, so we need like the front end and the back end. So we're using yarn for that. Then yarn chain brings up your local blockchain. You'll have a local blockchain running thanks to hard hat, and then yarn start will fire up your front end. That's what renders this here. So just follow that repo, and you can kind of get in, and there's documentation. There's the same kind of learn Solidity that I have here in the speedrun. So it should be pretty straightforward and pretty easy to jump into. Okay, so let's just go learn. Let's see what's next. Let's do the set purpose first, right? Let's clean this out. The contract you start with. What was that comment up there? Oh, it was an event. Okay, the contract you start out with looks just like this. We have this string that we're calling purpose. So you've got some storage in your smart contract, and then you have a function to update that storage location. So then let's see. Let's go ahead and do something like this. Let's get it deployed and get this whole app back to the starting point, like MetaMask does. A lot of people will do something like, let's go ahead and yarn deploy that code myself. And if we go to and these vending machines are like, oh, now we're going to compile, and we can zoom in on the withdraw statement, right? So boop, boop. Okay, right, either one, right? It's like, okay, well, maybe or we say not even no space, having this require every time, write that into that something NFT. Okay, now we should have, so front end that, and this is the point, is you need to build a contract, to learn how to stake into a second contract that is the vendor contract goes in there, it's going to reveal what the heck is a really crazy thing to discover. These T pairs really super. There's this really cool branch of scaffold ETH called sign in with Web3, where it sets you up with an app where someone connects their wallet and then they sign a message, right? And that goes to a backend server and verifies that message was correct and posts it up here. So you can sign and recover messages using this server, and you can verify them with the server. So you can do this kind of sign in with Ethereum. And by the way, if you go to like austingriffith.tv, there's like a live example of this where if you sign a message and prove that you have Ethereum, there's like a video where I chug a beer at the end or something like that. So these message signatures are really powerful, and you'll learn that in the speed run. And what you'll do, what's really cool is then these signed messages can also be recovered from within the smart contract. And by the way, that's what happens in that last signature of that state channel too. And what happens is not just signing and recovering off chain, but I can sign a message and send it to a smart contract, and the smart contract can recover the person who sent it, which allows all sorts of things. Like I hint at meta transactions here, but basically like I sign some kind of call day, I sign some kind of message, and I give it to Alice, and Alice pays the gas and puts it on chain. And then the smart contract takes that transaction from Alice and looks in there and gets the meta transaction out and checks to see who signed that. And sure enough, it was me. And so the smart contract can say, I don't care who submits it, but whoever signed this meta transaction, I'm going to do something on their behalf, or it absolutely has to be Austin, or this couldn't work, or something like that. So that's signed messages. You'll go through that as part of the speed run. And then once you have the sign messages you want to do, just real quick, you want to look at these the applications here. So many good applications and also hacks. Like learn how all the hacks work. Just dig through these. Just it'll give you such a better perspective of how Ethereum works by learning how all those hacks work. But build a multi-sig wallet. Build a smart contract that will track transaction data and then have people vote on it. And if 3 out of the 4 people signers on this multi-sig say yes, then you can execute that transaction. And it'll be the smart contract executing it, right? So it's like we have this smart contract and we all vote to buy an NFT. And if 3 out of 4 of us vote yes, then the smart contract goes and buys that NFT, and now the smart contract owns it, right? We would have to set up a new transaction to go like send that thing from within that NFT out of the multi-sig or something like that. Kind of hinting at a DAO, right? Most DAOs all only need a multi-sig, but eventually you get more complex stuff. So right in here, we've got this multi-sig wallet. And once you've learned that, you're ready for like the final project of the multi-sig. And that is to build a signature-based multi-sig. If you can build a signature-based multi-sig, there's a couple tricks and some gotchas. It's not that complicated, but once you can do that, like I can take your challenges that you've built on Scaffold and I can level you up to a handful of places in the ecosystem. Everybody's looking for Web3 developers, but it's so hard to figure out who's actually a Web3 developer, because once you get up and dump up that Dunning-Kruger and you learn the language and someone says, can you build a great smart contract? You're like, heck yes, I can, because you think you know everything, but you have to go through this whole speed run. You have to go through all these gotchas. But once you have all of that, it's gonna be really easy to get hired in the space. It's gonna be really easy to upgrade to, like, now I want to start learning auditing or higher level stuff, or I want to just build my own product. And this will get you dangerously close to doing that. I want to look at maybe like 1 or 2 more really interesting examples. Speaking of that multi-sig, I think the Gnosis Safe Starter Kit is one of them. Oops, this is the OpenZeppelin one. Let's see, Gnosis Safe Starter Kit. So what we're seeing is, as I talk to a lot of DAOs, they don't need a really expensive, a really in-depth smart contract for some of the things they need. What they really need is to be able to prototype quickly. They need to be able to still be sufficiently decentralized, but prototype and build something cool. So this Gnosis Safe Starter Kit is kind of this really handy thing for this. Basically, it's a Gnosis Safe. It's kind of like a smart contract wallet / multi-sig, right? It's a really complicated multi-sig that does a lot of other cool things, but it's basically a multi-sig where you have multiple signers, you have some threshold of signers that you need to be able to send something, and that is pretty decentralized, right? If I have 15 signers on that and I have to get 8 of them or 12 of them together to be able to make a transaction work, then basically like we're voting each time, right? So the Scaffold or the Gnosis Safe Starter Kit is saying, hey, build your decentralized experience. Build one of us signers, you land on the page contract we built 2. I'm going to keep talking up. So it says, once reach out to me on, I see someone say, would it make sense to migrate existing projects? There's a really cool way to do that since Scaffold kind of has this smart contract editor. A great way to find out if you want to go to Scaffold is to just take your smart contract and paste it into Scaffold. And it'll take a little bit probably to get the version numbers and everything right, but then you yarn deploy. And as soon as you do that once, you'll have like this whole front end that's already like ready to go, that like knows everything about your smart contract and you can tinker with it. So it's like once you get that far, usually you're like, oh wait, this is actually really easy to migrate. So I would say definitely if you want to find out if you want to migrate to Scaffold, to just try pasting in that smart contract and go from there. Let's see, realistic time span. You could complete I mean, like if you really did it quickly, I could probably complete the speed run in like a couple hours, but really it should take you a couple weeks if you're learning it slow. I mean, maybe a week, but then like you'll do a week of the speed run and then you'll do a week of maybe like building your own projects or extending a few different things. And so like within a couple of weeks, I think you can really get up to speed with a lot of things in Ethereum, but there's always like blind spots and things like flash bots and MEV and there's always a deeper rabbit hole to go down to, but just like you can scratch the surface of Ethereum in a couple of weeks going through all of these different topics. Boop, 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 boop. Awesome. Hopefully there'll be a recording of this. Let's see.
There will. Let him explain himself a little bit better than I probably can. He's got an extensive resume.
Looks like there's rain up ahead, like there's a crack in the heavens. Feels like my day could be turning, like I can tell that my luck's gonna change. If you could see me now, I'd probably let you down, but that's enough for me. You got me begging, baby. Looks like I'm on my knees again. Feels like the walls are closing in. Looks like I'm on my knees again. Looks like the tables have turned, like there's a change in the weather. Feels like my time is returning, like I'm about to get out of this cage. If you could see me now, I'd probably let you down, but that's enough for me. You got me begging, baby. Looks like I'm on my knees again. Feels like the walls are closing in. Looks like I'm on my knees again. 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 Looks like I'm on my take some time, come with me. I've never been one to wait, so give me your everything. 'Cause every time you look at me, I see myself in your eyes. I see myself in your eyes. Night swings in the rain. Wanna take a trip up the street. Fingertips on your waist. You and I feel the same. I've never been one to wait, so give me your everything. 'Cause every time you look at me, I see myself in your eyes. 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 I see you in everything. I see you in everything. I see myself in your eyes. I see you in everything. I see you in everything. I see myself in your eyes. I see you in everything. I see myself in your eyes. I see you in everything. I see myself in your eyes. I see you in everything. I see myself in your eyes. I see you in everything. I see myself in your eyes. I see you in everything. I see myself in your eyes. Let me tell you about a little situation. It's been She was keeping me up all night, 'cause you only get so far reading faces. We were off to the races and I thought to myself, hold tight. You see, there was just this one complication. She was already taken in what was so wrong felt so right. She said no need to be looking over your shoulder when you could just come over and we could work this out just fine. I don't know what So high, do you think of my Someday, the sky is crying. Someday, I'm laughing at the moon. Someday, the sky is crying. Someday, from always being blue. Someday, the sky is crying. Someday, she says our time is due. Someday, the sky is crying. Someday, crying for the world she knew. Someday, she said love was something that she thought she could understand. But that was way before her heart was broken by a man. Oh, she's crying. Oh, I see her dying. The clouds are coming in and as she cries into a river. Stars are shining bright, only when you couldn't see her. Oh, she's hiding. Inside you see she's trying. The sky is crying. I'm laughing at the moon. The sky is crying. From always being blue. The sky is crying. She says our time is due. The sky is crying. Crying for the world she knew to be loved. Your love is like a storm. Your love that she couldn't hold on to. Yeah, your love is like a storm. Your love that she couldn't hold on to. The sky is crying. The sky is crying. The sky is crying. never too late to leave yourself behind now. Oh, it's never too late if we know what we're looking for. You need a little conversation and some good vibrations headed into consummation. Baby, thank you for your patience. You always keep me waiting, trying to build up the sensation. I know what you're doing. 'Cause when you reach for me, I'm there, I'm by your side, and you're holding me. I'm alright, I'm alright. I wanna hold you, I wanna touch you, I wanna feel good and make you mine. Reaching for me, yeah. Reaching for me, yeah. Reaching for me, yeah. spectrum of love, down to zero. It's hard to remember just one good day. Everything is faded. Just one good day. It's hard to resist now. Everything is faded. Was never meant to be this way. Everything is faded. It's hard to remember just one good day. Everything is faded. Was never meant to be this way. It's hard to remember. Just one good day. Everything is faded, 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 faded. And so are you. the smiles I gave, all the love you've taken. There's a line to break. Can you hear me drown? Can you hear me drown? Can you hear me drown? Can you hear me drowning? All the places I've been, all the smiles I gave, all the love you've taken. There's a line all the places I've been, all the smiles I gave, all the love you've taken. There's a line to break. Can you hear me drown? 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 Coming. gentle treats. Make you search your inner core. And against your expectation, you keep your dreams on a leash. Reminding you, reminding me. Neglecting the intercourse. Reclaiming the invitation.
Nothing around us. Nothing around us. No time, no space, no lights. Nothing around us. Nothing around us. No time, no space, no lights. nothing around us, nothing around us. No time, no space, no lights, nothing around us, nothing around us. No time, no space, no lights, nothing around us, nothing around us. Nothing around us, nothing around us, nothing around us, nothing around us.
Okay, so I think I'm beginning to understand how everything works here. It's very complicated because of all of these components that are nested together, so I think it's gonna take me a long time to figure out how to make it work on my case here. But I think now, after spending a bunch of time with this, I kind of get it. And I think the main components that I need is this load web3 model and the logout. And I think I'm gonna have to pass this as a props in the navigation as well. And that way I can use these things instead of using, that's why I put these variables here. The only thing that I'm not sure is if that's necessary or how I'm gonna get the connect and destroy. I don't know how to associate them very well yet. And then on the other pages, it's probably pretty much the same thing, where I pass as props here, and then instead of using the kit as I was using before, I just pass the load web3 model and the logout web3 as well. And that should be enough to keep track of the connection of the wallet. So I think I'm much more clear now on how it works, but I'm still very confused. So it's gonna take some time, and then probably the first times that I try to run this is probably gonna give me a bunch of errors, and then I'm gonna have to figure out. And honestly, it might be worth it to look into easier ways to do this, because if I spend too much time on this, I'm definitely not gonna be able to ship anything by next week. But I think worst case scenario, I just do like I said before, which is just ship with the front end and not build the back end. Just so I have something to show. But yeah. The thing is, I have to start this thing here and see how it works on the front end. All these components work, because there's a lot of things here that are not going to be useful for me. So I have to figure out which things I have to remove on my stuff in order to make it work. So I was thinking about doing the Ethereum speed run again, and this time trying to finish because now I have enough money on the wallet to deploy the contracts and see how it works. So I think that might be a good idea. I'm just worried about the time, how much it's gonna take to finish, because obviously I don't have a lot of time. And then if I spend too much, if by Monday I still haven't figured out how to do this, following this project, I'm just gonna do it the easy way, which is choose the window, the Ethereum, the window object, and or use the hooks on Web3 and pass them as props and keep track of the connection like that. I think all I have to do is use these hooks here and then pass as props for these elements, these components, where I need the address, and yeah, that's pretty much it. Shouldn't be that difficult. The difficult part comes on trying to integrate all these other components, because I think using these components is gonna be better. It's just more, there's more information, and it's probably a better way to design things, since this guy probably knows what he's doing. So this is probably the best way to do it, which allows network, changing the network as well, and keeping track with using the local storage as well. But I need to keep in mind the stuff that I need here, because I still haven't really understood yet to make this connection. I have the address, so the address I think is fine like this, because I'm getting from the load Web3 model, but the destroy and connect button, I'm not sure how I'm gonna integrate here, because here I think he's placing on this network stuff here, network switch, and on the other network display. So maybe it's just the logout Web3 model, the disconnect button, I assume. I'm probably gonna do the same thing actually. But here it doesn't seem like he uses, that's the thing. Which is weird to me. Let's see on the account. And the account that he has there, here. Cached provider. I don't understand this but really well. But I guess what I can do is, I guess the thing he's doing here with the account is the same thing that I'm doing with the navigation, with this button here, this condition. So I'm either gonna keep the account and erase this, or you can check the Discord in the description below. And I'm sorry if I can't help you now. I'm probably gonna stay awake the whole night, and once it's morning here, I'll be able to talk more, talk louder. But I'm trying to be quiet now because it's already late here. I'm just talking here because I'm gonna pause soon to go make coffee and eat something. Yeah, I don't speak Spanish. I speak Portuguese, which is close. But in the stream, I speak English only. I think it's English in the thing that I put. Oh, I see. So what I'm gonna do is I think I'm gonna either put this on the navigation here. I think I'm gonna do this now actually. Like this. And then a pass Web3 model here. Or here. Well, actually it's better if I pass with the names. Oh shit. Web3 model, loads, logouts. So I assume that what this is doing is the same thing that I'm doing here, that I was doing with this logic here. Like this. Yeah, he has a button here. Shape round. And click. Yeah, so I guess, and maybe I don't need to, I can erase this part here and just have the account. It's probably better. Because that's all he's doing here. And that way everything stays on the same page as the application. And I can just keep the logic for handling the wallet separate from the navigation. In the same way I did here. I think that's what I'm gonna do. It's a little bit scary because I don't wanna delete the stuff that I did and fuck it up, but I guess it's fine. So I'm gonna take a break here. Just I'm gonna take a break. I'm gonna do some coffee. I'm gonna cut the stream here. And probably in a few hours, maybe 1 hour or two, or maybe even sooner, I'll come back and I think I'm gonna watch this video here. I'm gonna finish watching this video. Then I'm gonna keep working on this. I think I'm gonna do what I just said with the account. Erase the button there. And I'm gonna try to restart this and see if it works or if it's giving me any errors, and then I'm gonna try to fix them. And my goal is to finish this integration, this connection with the wallet today, hopefully, and then start working on the other stuff. So yeah, see you soon.